Okay, and we are live.
HashiTalks Africa, welcome. I'm so glad that we've managed to pull this event together again. Thank you everyone for joining us. My name is Rob Barnes, also known as DevOps Rob. I've had a quick look in the YouTube chat. I can see so many people have joined the stream. Some familiar names. Shout out Rexford, good friend of mine from Ghana. Thank you so much, everyone, for joining. This is going to be a fantastic event. This is a celebration of some of the talent that we have all across the continent of Africa. And I'm really interested to hear people share their stories and their practices, their workflows, how they're using some of our tools and how they're just generally making the world a better place just with the skill set. So really excited to hear more about that. So welcome, as we say in Ghana, Akwaba. First thing I want to point you all to is our code of conduct. We'll actually post a link to the code of conduct in the chat. But just generally speaking, just be kind, just be polite. Just make this a really nice place to be, and just a good representation of the community that we have built. So yeah, we'll make sure that is posted in the chat. I also encourage you, if you're on social media, to engage in conversation around the talks. So please use the hashtag HashiTalks, and we'll try and highlight some of the tweets if you have anything nice to say. And who knows, we may select some really special tweets or anything like that and send out some goodies. It could be some swag. I'm not saying it's going to be one of these things. I'm not going to tell you what the swag is, but let's just see. So yeah, just use the hashtag HashiTalks, and that'd be fantastic. And we'll see if we can highlight something going forward. But yeah, without any further ado, let's introduce our first speaker. I'm really excited to introduce Obinna. Obinna is going to give us a talk about better developer workflows in infrastructure as code. I'm really excited to hear that. So over to you, Obinna. Take it away.
Thank you so much for the quick introduction. And today we're going to be talking about a better developer workflow in infrastructure as code. And let me quickly introduce myself. My name is Obinna Otirionye, and I'm a Kubernetes engineer at Kubernetes, and also I'm the member and maintainer of CNCF Helm, working on chat museum. So yeah, and my pronouns are basically he and him. And you can also catch me on Twitter at Ojironye, and then we can, in case you have any questions or you want to discuss or just hang out, let's do that. And yeah, send me your favorite memes. I love memes, more memes, or whatever you call it. So let's go back to the beginning of infrastructure as code and how it all came to be, because then in the DevOps world, we can all say that then if you wanted to ever spin up infrastructure, or you wanted to create, let's say, like 10 buckets or 10 virtual machines on the cloud, you basically maybe have to like write some bash script and then call the SDK of the cloud provider you want to tune into. And this makes your bash script really messy. You cannot really do that at scale. There were tools like Ansible, but Ansible wasn't great enough because Ansible helps you in configuration management, right? It doesn't really talk to the cloud providers per se to spin up these instances for you. So this has really become like a huge pain in the neck over the years. And when we dive down, you also discover that there are a lot of great IAC tools right now. You have things like Terraform, you have Plumni, you have AWS CloudFormation. It's proprietary basically for AWS resources. You have Google Cloud Deployment Manager, a proprietary software tool for Google Cloud resources, and Azure Resource Manager. So yeah, and this are pretty interesting tools that you can check out. But today, I just wanted to be focused on Terraform. That is what we are going to be talking about today. So let's talk about why Terraform. Like, why exactly did I pick Terraform, or why exactly would you use Terraform, right? And one of the things I love about Terraform in relation to other tools basically is it is agentless. You don't actually need a server to run Terraform. You do not need anything. You need something as simple as the binary and your code base and then your credentials, and things start working instantaneously. Another thing why I actually love Terraform is reusable module components. So that means I can take code that I have used maybe to spin up a bucket, and I can use it anywhere around my infrastructure as code file, basically. So I could create a bucket somewhere as a module and then import it into another module and use it there. Like, it's really, really great. Like, it's a really great feature because it saves you time for rewriting that code all over and all over again, and it's amazing. That feature is really amazing, and it has a very large community. I cannot tell you how happy I am about the community that is backing Terraform. It's so, like, if you go to Stack Overflow and you have any problems, you see a lot of people are out there to support you, to help you, and also you have like the Terraform or HashiCorp group where you can actually go and then ask questions. I think it's on a discourse. So the backing is really great. And also, it is the most starred IAC tool on GitHub with over 3,000 stars and counting. This is a huge feat for Terraform. So today, we're going to actually have some talk basically about developer collaboration with Terraform. And let's dive deep into that. So when we think about developer collaboration, in 2018, HashiCorp to be precise, there were some great features that were announced about Terraform that we enjoy today. And one of those features basically is state management. So what state management means is that now you or one or more developers can work on a single Terraform like code or in the repository. So you don't have to worry about having issues with your deployment, or if this infrastructure works, or sharing data across different providers. As long as you have a state and then you have it in a remote, like a bucket or a place where you store it, you can actually work on these tools together. You can work on the code together. Another great thing, like I said, I love initially was reusable Terraform modules. So like I said, you can actually import information, or you can import your code from another module to another module, and it's reusable everywhere. And the great thing is the centralized Terraform plans and applies. If you ever use Terraform Cloud, you would see this feature is really dope. So that means anywhere across this, you own the deployment. So you can do plans or applies anytime you want to. So let's also go deeper. One of the things that basically got me into submitting a proposal for this conference, because I wanted to talk about the tools basically and what it does to our developers, to the DevOps engineers, or to the software engineers, especially when they're using Terraform. And one of those things basically is less visibility. Now, when you go into a larger infrastructure, what happens is you have all this so much log. Sometimes you don't know how to distinguish which from which. I've been in a scenario where I have deployed close to about 300 resources, and then the logs get really, really cumbersome. So it becomes very hard. You can't really you find difficult focusing on what you're trying to change. You know, sometimes Terraform Plan actually looks very, very insane. And also, you have a poor review process and then less collaboration. So the poor review process comes with you barely don't know what is going to be deployed yet. You obviously have to go through this issue of going to check out the PR and then look at it and then try to run it, and then you might have to like share secrets. It gets really, really crazy from there. And then less collaboration, because then you have to share secrets. Like I said, it becomes difficult because you don't know exactly what is going on in that code base. So you basically maybe going on Slack and finding out, okay, what does this do? What does this do? And so much things that has to do with the tools basically that hinders developer workflow. So there is a solution. There is a solution, and that solution is Terraform with Atlantis. And this is very, very. When I found out this tool, I was blown. Like it's what we have been waiting for. It's astonishing. And what Atlantis does is that Atlantis is a Terraform pull request automation tool. It solves the toils basically with it and gives us a better developer workflow, which I'm going to show you in a demo. I'm going to do a demo that shows you two things. First of all, the way a natural CI/CD setup in an organization and how Atlantis solves this issue, basically. So this gives you increased visibility, enables better collaboration, makes your code review process very, very smooth. And I really think we need to try it out. And we're going to actually try it out today. And there's been so much talk. So I just want to jump right into the demo and I show you what I have. You can actually go to this repo and have the source code for this particular talk. So right here on the on my machine, you can see I have a bunch of Terraform code. So I have actually used some modules, some I have forked. So what this module or this Terraform code is supposed to do is to create a VPC on Google Cloud. Yeah, on Google Cloud. And then it has a remote state. This is where I am going to be storing the state configuration. And also it's going to create a virtual machine. And then we have an instance template, basically. So the instance templates are just like a config that the VM module is going to use to tell it, okay, what kind of operating system do you want to be running? What is the size of disk you want to have, and all that utilities. So I am just going to go ahead and run this first of all. So this is going to be Terraform init. So the Terraform init is to initialize the repository and all of that. And then we're going to go into Terraform Plan. Terraform Plan. So I'm going to say exactly what resources are going to be deployed today. So that is what it's going to. So we can see it's going to create 14 resources, and there's a whole lot of logs here, basically telling us the configuration that have been set and all of that. So we can go ahead and apply that actually. We can go ahead and apply that. So we're just going to give it some time and then press yes for it to apply that. So what we are seeing here is what happens in an everyday or day-to-day in approach of a DevOps engineer. You create modules and then you apply them into you deploy them into the infrastructure you want. It could be Azure, it could be GCP, it could be AWS. I know one of the great things I love about Terraform is like it's written in Go, so it's super fast. It's a really great tool to use. So right now it's creating the VPC that we want to use. Real quick. Okay. Just gonna give it some time. So right now it's creating the virtual machine. So it's done. It's done. Now this is the great thing. So now right here, I wrote this custom tool that basically exports the backend. So if I come into project, you will see a backend.tf file here. So what this does basically is to allow me push my state file, which is located here, to a Google Cloud bucket. So I'm just going to initialize this again, and then we're going to see that. So it's going to push that, and this place automatically will become empty. So let's see that in action. So yes, I want to push that in. Great. So now we can see this place is empty, but we still have a backup of it. So we're going to push this now to GitHub, and then we're going to see how that works in GitHub. So I'm just going to quickly go back to here, and then I'm going to copy this and push to Git. I'm just going to create my secret real quick. Terraform, and then my secret service key. Yes. My secret key, I'm going to add it to actions, and it's going to be called, and I'm going to paste my service account name. So I'm particularly a big fan of using this. I'm just going to say this, repeat copy, just to avoid this. I'm going to add secret. Okay. So what is going to happen is I am going to update this now, and I'm going to push it. Yes, and I'm going to say update. So now we can see that a CI has kicked in, and then it's going to do a plan for us. And then after the plan, it's going to apply, it's going to check for the code. If there's any issue, it's going to let us know. Let's see. It's going to do a format check also on it. Okay, so you can see it's actually now doing a plan. Great. So this is what we have issue. Now imagine if you're working on a big infrastructure. Let's look at this. What I'm going to do now is I'm going to create another branch, and I'm going to call that branch an update branch. Okay, already exists. Let's change. Let me do this. I'm going to say checkout, then B, and I'm just going to say, what do I call it? Talks. Yeah. So let's call it that. And then I'm going to update this real quick. I'm going to update the infrastructure. So if I go back and I say I'm going to change the, let's say this, I'm going to change this, and I'm going to say, okay, deploy Ubuntu 18. Okay, and I'm going to ship this real quick. So what's going to happen is I'm going to create a PR for this. Exactly. And then it's going to, so what this is going to do now is going to just run an init and a plan, and then show me what is going to be deployed. So this is great, but the problem with this is as you keep on going bigger on your infrastructure, it becomes very, very cumbersome because the logs get so much, and then you might not necessarily know exactly what needs to be deployed. You could miss out something. It's going to be very, very hard to debug from there. So these are all the things it is going to deploy right now, but this can actually get really, really difficult because then as your infrastructure goes wider, you don't need to see all these states, all of that. Your main information starts from here. So we are going to solve this issue because this can become very, very tedious, and you honestly don't want that, especially when your team is growing bigger and bigger and bigger. And mind you, one thing I also wanted to talk about is the Terraform. I'm still going to show you the Terraform locking in this demo. So for now, I'm just going to do this. I'm not going to merge this now. I am going to show you how Atlassian works. So the first thing I'm going to do is to start up my Atlassian server. And it's like, first of all, I need to create a tunnel. And so I'm going to just do split down right, not this. I'm going to close this real quick. Close. I'm going to do split down, down. Yes. So here I am going to actually start up a tunnel. I'm using a local tunnel if you want to. It's a great tool, and I'm going to be listening on 4141. So what I'm going to do right now is I'll copy this URL and then add it to my repository webhook. And this is very, very great. So if you are doing this, please, on the setup, you can just check out the README I have added, and then you should be able to see the information on how to set this up. So I'm going to update this. Yes. And I'm going to come back in here. And I'm going to start my Atlassian server. So what I'm going to do is to just say make run. I have written an automation tool for that. That should solve that. So I'm just going to copy this. And then I'm going to paste it, update my env. My env, yes, with this. Before I continue, I also need to change it because I'm running from my system. So I need to change where the credentials are basically going to be stored. So if I go to my Google Cloud providers, my credentials, I'm going to change here. I'm going to change display. I'm going to do this. And I'm going to uncomment this. Or rather, comment it out here. And I'm going to take this also. So you can use like a virtual machine, a dedicated virtual machine to do this, it's fine. And also I'm going to have to go to backend.tf and I'm going to update this too. I'm going to comment this out. I'm going to update this. I'm just going to do Terraform format to make sure that if there are any issues, it just does that and voila. So I'm going to push this. Great. So we can actually go ahead and then start up our server. So if I do make run, so we can see that our server is actually started now, and we can see that here. I'm going to go here and I'm going to comment on this PR and I'm going to say Atlantis plan. I'm going to comment this. What it's going to do right now is that it's going to send, it failed. Okay, debugging starts now. It's locked by another. Oh, I see. Let's see. Okay. Okay, plan error is great. So yeah, about. So now what we can see here is what exactly is going to be added into our infrastructure and what is going to be removed. So from here now, you can see it is way easier. I did not share any secret to anybody. Any user can come right here and then see exactly what they are going to be deploying. And you know, it has this nice user interface where you can actually see, like there's a dashboard here. So you can actually see what is being locked and who is using it at this moment in time. As you can see here, very great UI. And this is basically what just happens. So this is exactly how we solve this issue. So your developers can now come in right here and then see exactly what will be removed, what will be added. And then you can still go ahead and use Atlantis apply. What is going to happen right now is that it's going to go ahead and apply this infrastructure. So let's do that. Comment. And then it's going to kick up. So we do apply. And then we can see it's currently applying. Now, the great thing about lock now with Atlantis is that if somebody comes into this PR and then puts like an Atlassian again, and then puts Atlantis, sorry, and then put plan, it should not work because another process is running. So you really don't want it to mess up the infrastructure. So if I come here and I put plan, it basically shows you this. So until this is done, which is the apply, before we can actually go ahead and then run any other command. So you can see basically has failed it because it's not going to run it. Another utility is using it. And if you come here, like I said, you also see that. So this is one of the great things about using Atlantis. Now, if we just do that, and then we're just going to allow it to apply, it's still applying, it's still applying, it's still running. I can see it is done. Great. So now we can now see the information we want. We can see what was destroyed, we can see what was created, and then we can now see it was complete. This is the great thing about Atlantis. And if you even go down, now you can now finally even check out the plan, and then it should work. So if I go back and put Atlantis plan, and then comment this, we should see the plan kick in again. So there are a lot of powerful things you can do with Atlantis. You should check out their documentation. You can set up approvals. You can do great things. You can set up workspaces with Atlantis. It's a really, 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 really great tool. And it just runs at the background here. So as you see, it just keeps on going and going and going and going. It's really, 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 really great for collaboration with your developers. As you can see, no changes are required for the infrastructure. So we can go ahead and then merge this into our code base and then confirm merge. And it's done. And then you can delete the branch. So this is one of the most interesting things about Atlantis that I really, really love when you're setting up your workflow for your developers as DevOps engineer, or even as a software engineer. So that is it. One of the things I want to really say is I believe this is not the end to a better workflow, because I mean, we will keep evolving, more features will be out, and then we'll be able to make better use case of the tools we want. But I believe also that this is only a means to achieve it, and we are just scratching the surface of IAC. The best is definitely yet to come. So thank you very much for listening to my talk, and have a wonderful day. Bye-bye.
Thank you so much, Abina. I have to say, there are so many things in that talk that I can personally relate to. In the beginning of the talk, you mentioned some of the other tools that we were using. So things like Ansible. And I ran into some of the same challenges where every time you go to change something, it's running through the entire thing, and you risk, unexpected changes to your infrastructure. I went through the whole cycle of bash scripts, and I was mind blown the first time I discovered Terraform, and I haven't looked back since. Interesting fact: Atlantis, which you demoed in the talk, it was actually originally built by a friend of ours, a guy called Mishra, who actually used to have the same job as me, developer advocate. So currently works at HashiCorp. I'm not sure if Mishra maintains it anymore, but it's a really cool tool. I have actually posted a link to the project in the chat. There's been a lot of interesting conversation in the chat around this workflow and some of the things it can do, and how you can, go for a better code review process with your Terraform. So highly encourage people to check it out. Atlantis is an awesome tool. I had the same reaction when I first discovered it. And I haven't really looked back since. So it's fantastic. Just a reminder to everyone, it's been fantastic talk in the chat. Please keep it up. Abina, thanks so much for giving us the talk. Thank you for hanging out in the chat and answering the questions. Please do keep the questions coming, keep the conversation flowing. And if you are on social media, also try and take some of the conversation over to social media as well, using the hashtag HashiTalks. So without any further ado, let us introduce our next speaker. This one is a fantastic speaker, which we actually had last year as well at HashiTalks. So really excited to bring her back. I would like to introduce Anita to the stage, who's going to be talking about quality onboarding, a ticket to a healthy open source experience. So Anita, over to you.
Hey everyone, my name is Anita Human, and today I'll be speaking on the topic quality onboarding, a ticket to a healthy open source experience. And if you're new to open source, or of course we've all been through the beginner phase, you must have experienced this onboarding process, and it could have either impacted you in a good way or in a bad way, and we're going to be discussing some of that during this section. So let's get to it. But before we get into the topic, a little bit about me. I am Anita Human. I'm a technical writer at Apache API 6, a cloud-native API gateway under the Apache Foundation. I'm also a developer advocate, previously at Kivano. I am an open source fangirl, and I say this because I think my entire career has been built around open source organizations, communities, and interaction. So yeah, I'm an open source fangirl. I love cats. Yeah, that's another thing about me to put out there. All right, let's get into today's topic. So during this section, we're going to be looking at these topics. We're going to be looking at what exactly open source is, how does this affect us, then the common onboarding mistakes that have been made in open source communities, the consequences of poor onboarding to both the community and individuals in that particular community, and how this can be improved. And finally, we're going to look at some of the rewards that quality onboarding can bring to a community, to a project, or to open source generally. All right, let's get into it. So before we discuss on the problem, let's identify what onboarding is. Well, onboarding is simple. Like if I'm putting it in basic terms, I'll just say it's welcoming people in, the proper way of welcoming people to a community. That's exactly how I put it. But then onboarding is the process of formally introducing and integrating newly recruited members of a community through the basic knowledge, the skills, and the behaviors that are needed to excel in that particular field. So it's basically you putting the newcomers in your community, the newcomers for your project, the users of your project through the step-by-step guides, through a detailed roadmap on understanding your project and navigating around your project or your community. That's basically onboarding, right? Well, how can something so easy and something that sounds so easy even be, not be done properly? How can someone flop with onboarding? Well, let's look at it. Well, for several experiences contributing to open source, I have heard a lot of persons share their opinions of how they're not properly onboarded in communities. The onboarding in the communities made them take certain decisions or act in certain ways. And some of this is onboarding has affected several persons in different ways. For a community, you might see that there are lots of abandoned tasks, pending tasks that were delegated to contributors or to the maintainers, thinking that they would accomplish these tasks, and at the end of the day the tasks were left halfway. Then reluctant to contribute. Of course, most communities, you see, they have so many contributors, and if you're listing out the number of contributors that join the Slack or the discussion channels, there will be over 1 million persons coming in, but these persons are not willing to contribute. They're just in the chats platforms and probably not engaging at all. Then communities also experience the reduced productivity. Now, if the community members and the maintainers and all of the contributors are not willing to collaborate and are reluctant to actually make efforts to grow this community, there's definitely going to be a gradual reduction in the productivity of that particular community or project. And then finally, no commitment. Now, a community that does not, give the newcomers a warm welcome is most likely going to lose those newcomers the same way they came in. Now, I'm talking based on my experience, but I know a lot of persons also have experienced the same thing. So it definitely is not speculations. If a community does not give you the warm welcome that you need as an individual, you feel like maybe it's because I did something or because of this particular thing. And as a new contributor, there's definitely going to be that doubt on why people are not giving you the attention that you need to contribute to this project. So Now, this is how poor onboarding affects our community. Now, let's look at how it affects individual contributors. Well, you experience withdrawal as an individual. Several persons have done this. And during my contributions in a few open source communities that I experienced, I didn't receive the quality onboarding I thought I needed. I ran away. That's just the truth. I ran away because I was mentally prepared for that. Then we also have resentment towards that project. A lot of persons get furious when they're not able to figure out things, and at the end, they transfer the aggression to the community members that did or didn't contribute to all of that, or the maintainers that are just managing the project on behalf of the project owners and all. So you hold so much resentment as a contributor simply because you're not welcome in the best ways that you feel you should. And most persons experience burnout because the process of learning this all on your own is tedious. And so a lot of persons end up being burnt out because they don't have like a detailed roadmap on how to navigate around this community. Also, you experience nonchalant attitude towards the contributors and the members of the community generally. And of course, there's no dedication to contribute because you're just here because it's open source. They say it's open source and you've not really seen, you don't know what the community is all about. You don't know project this community offers, but then you're just here. Let whatever happens, happens. That's why a lot of contributors who are not properly onboarded and look at most open source communities. Now we can see how this affects us in several ways, but then what are the common onboarding mistakes that have been made in the open source community? Well, there's several, a lot. And most times open source communities give, when they receive new contributors, they focus more on this distributing the tags, giving them areas of project to fix and all of that without putting in like enough effort into making sure these persons are comfortable with the knowledge they have gained about this community. And some of these problems, some of the common mistakes that I have experienced and of course observed from most open source communities is the assumption. And there's always this assumption that they'll figure it out. They must have read it from our documentation. But what if I tell you today that they most likely didn't read your documentation? In fact, they didn't figure it out. As a new contributor, I'm too scared to do anything that I don't go about snooping into your documentation, and I'm too scared to do that. So I'll just wait for someone to, give me the heads up. If you want to do this, you need to find this. As a new contributor, I'm the lazy contributor. I'm the lazy kind of contributor that feels if someone from the community does not give me heads up, then I might not be able to figure my way out. I'm that kind of contributor. So what happens with your assumptions that everyone is going to read their documentation? What if I end up reading your documentation, but still I don't get the knowledge that I'm looking for because your documentation is not even to the standard of being a tool for onboarding me, because I know a lot of documentations are structured that way, too technical for newcomers or persons who are new to the system to understand, and that is another mistake. And then we also have the generalizing. By generalizing, I mean generalizing that, of course, it's open source, so we know that there are going to be contributors from east, west, north, and south, and these contributors from different parts of the world or regions of the world come with different perspective and different beliefs and orientation. You might be trying to onboard someone from a country and use certain terms that give them the impression that you're being offensive to them without even knowing it, without even realizing it. And at the end of the day, you're going to say you did a proper onboarding experience, you gave them the resources, you did this, but the contributors themselves felt attacked from the day one, and at the end of the day, they bail on the project. So that's not what we're looking out for. And then we're looking at negligence, of course. Most communities, once the contributors get into the communities, they start distributing issues. Like I said, you're going to be seeing there's an available issue here. You can join our meeting, you can do this. But the newcomers are like high school students or someone who's just getting into high school for the first time without any knowledge of how high school works, or how the lecturers and all of that are able to, how to assess them. The onboarding process is like getting into a university or a high school for the first time as a student. And that is not, if you've experienced this, you know that it's not the most awesome or blissful memories, because walking into that school, the first thing you realize is you're not the only person here, and there are thousands of persons doing the same thing, learning. And that's exactly what happens in open source communities. Now you get overwhelmed from the first step, and if you're not properly, or if you don't get a guide that walks you through the school, the rules and the do's and don'ts of that particular school, you most likely make a mistake a few weeks or a few months into your journey in that particular school. So that's exactly how it works in open source. Once these contributors come in, if they're not like giving a tour around your community or around your project, they're going to feel neglected. And that's neglect, the negligence that you've showed these contributors, it doesn't just fade away over time. They're going to have it in their mind that this community doesn't really care about me. So if I'm doing anything, I have to do it for me. And that's exactly how the contributor would say it. Then there are too many unnecessary details towards onboarding. Now you're trying to educate me on your community, but you give me documentations that, like 10 documentations with, lots of content under it. And for once, the community or the persons in charge of this onboarding stop to think that, what if I don't know how to read? Or what if I have zero idea about web development or the tech ecosystem generally, but I joined this ecosystem or this open source community to, increase my skills and all. At the end of the day, you're feeding me with too much information. I'm going to get overwhelmed. I'm going to, get scared of this information, and of course, bail on the project still. Then we also have the incomprehensible documentation. Most of our documentations are so technical that if you're not so experienced, you have to read dictionaries while going through the documentation. And for a newbie, that is a huge turn off, because I don't want to have to be Googling while knowing about your project. I'd rather just watch a YouTube video to save me all of that, don't you think? And then the unclear learning curves. While you're onboarding these persons, set out a detailed learning curve. But a lot of communities these days do not have this, and it affects the contributors, because now you're being filled with so many information all at the same time. You don't know where to start from. Should I go to the documentation first, or should I check out the blogs first, or I don't know where to start. So like the learning curve has to be properly structured, but a lot of communities today do not have a clear learning curve for onboarding in their communities. Now, what are the consequences of poor onboarding? There's several consequences, of course, because when contributors and users are not properly onboarded, the community at large gets affected on a long run. And how do you mean? If I join a community, or paraventure I join a community today, the high tendencies that I'll be in that community for the next 2 to 3 years. And so whatever you give me, whatever information you give me today is the same information I'm going to give to the next contributors that will be getting into that community for the next 3 to 5 years. So if you give me the wrong information, I'm going to be distributing wrong information for the next 3 to 5 years. So the consequences of onboarding, we have quite a lot of those. First, is no trust from communities. So like when a community does not properly get their contributors on track, contributors do not feel the need to, feel comfortable, did not see the community as a safe place for them to, expand their skills, to bring in innovative ideas and all of that. They always putting their eyes or their attention out there for a community that might do better at every single instance. Contributors should be looking out for a community that does better than this one I'm in, because my community does not appreciate me. So I'm really skeptical about this particular community. That's basically how it works. And then we have the lower employee morale. Of course, when these contributors do not receive the do's and don'ts code of conduct of that particular community, they're going to live or experience this, exert their contributions in the best ways that they can. So you might see someone doing something offensive, and in their defense, they're going to tell you, well, I wasn't told this when I joined the community. And that is rather a painful thing to do, because most mistakes that I made at this point, I had to actually correct or affect a lot of persons at the end of the day. And then it slows the engagement level, because most of the contributors are focusing more time learning in the period where they're meant to be practicing, where they're meant to be contributing and making useful effort to the project. They spend all of that time learning. The learning curve that was avoided by the community, and they're compelled to do it on their own. So the engagement and contribution rates for the contributors is slowed down eventually. Then we have the reduced confidence among contributors. I know sometime I got into a community, and I was able to understand what the community does, but I wasn't able to tell a lot of people about this community. Now, it's not that they didn't make enough effort, it's because they didn't do it in the best ways that I'm used to learning. And so at the end of the day, I'm going to tell you I'm contributing to this community, but if someone asks me, what does this community do? I really can't say much, because I don't know so much. The best of my reading only told me that a line about this community or something like that. Then we have the results. It also results in poor performance. And when these persons spend so much time learning and doing, at the end of the day, you're going to see contributors that are making they're making useful contributions, yeah, but not to the standards of that particular project. Let's take, for instance, your documentation. You hand your documentation to someone who was not properly onboarded, a newcomer for a start, who was not properly onboarded, and who is also new to the project your community is offering. If they're to improve that documentation, there's no doubt that at the end of the day, your documentation will have so many lapses, so many errors, or reputations and all of that, because yes, they were not properly onboarded. They didn't understand the standards that are expected for your community on how the documentation for your community should be. All of that was not put in place. And so you're going to end up with a poor performance from these contributors at the end of the day. And then, of course, reduced productivity. The rate at which your community is meant to, actively collaborate and work together, growing your community, will be reduced, because so many persons are still trying to navigate around the community on their own. So they will most likely take more time of that than actually doing what is expected, which is improving the project and moving on to the next phase of the project or the community. And of course, the inability to retain these contributors. And like I said, if you're not given the best treatment, a lot of contributors, and that's why you see so many open source projects, they have like 5,000 Slack members, but only 10 active Slack members. And you'll be wondering, we did our best. Well, did you really do your best? Because if you're not able to retain these contributors, which means your best was really cannot be classified or quantified as your best. Now, inability to actually properly welcome these people and give them the resources expected to do the job is going to make them want to run away from your community sometime into their contributions, either a month or two. It depends on how much they want or how long they want to stay. But at the end of the day, the community is going to keep losing contributors rather than retaining these contributors. And in the end, this all come together to yield an unhealthy community, because you're going to see a lot of issues with the inclusivity of this community, because most of the persons that will stay back, if peradventure the contributors choose to stay, they might not be the contributors that you're looking out for, or they might not bring the diversity that you're looking for within your community. And all of this come together to attribute to an unhealthy open source community. And that is not what we are looking out for in open source. Now, how can this be mended or improved on? Let's say, how can we as open source community members work together to fix this? And there are different ways, but to tackle this, I'd always suggest you evaluate the existing rules for your community and go back and adjust your documentation, your guidelines on how to get people started. Evaluate your rules, see where the problem is, look at where you went wrong from the start. And by the time you identify this or identify the problem, you can now know what exactly you did wrong, where you went wrong, that these community members are not able to, be productive, or they're not able to, you're not able to retain these contributors in your community. And then you have to adjust your foundation. Now, by adjusting your foundation, there are several things that were existing before you got to realize that your onboarding process was not the best. Go back and work on the members, the people at the top, from the head of the community down to adjust the foundation. And of course, put out different interactive ways for people to come together. If it has to do with setting up hackathons, meetups, just to get your community engaged. And then properly put out the onboarding culture. And by the time you're adjusting your foundation for the project or for the community, embed onboarding as a culture, as a common practice among your members, among your contributors. That way, whenever someone joins the community, now you don't have to remind your maintainers or your community managers that, yes, we're meant to give this person a proper walkthrough on our culture, but they just on our community, but they just subconsciously do this. And so when you inculcate or introduce the idea of onboarding as a culture to your community, over time it's become an unconscious practice. And I'm going to give a simple example to this. I used to contribute to the Layer 5 community. I've been contributing for the past 2 years. And we started to restructure the onboarding steps and make sure that whenever someone gets into a community, either the maintainers, the community managers, or the moderators in the community reach out to this person, send out the useful resources, and answer their questions or doubts about the community before they even do or make any contributions. And this was something we decided to be doing. And over time, everyone in the community realized that, whenever someone joins our Slack or whenever someone joins our meetings for the first time, it is our duty and responsibility to put them through. Now, even if the maintainers are not available at the time, the moderators will definitely want to welcome this person and give them the necessary resources. Now, it became an unconscious practice for the community till today. And it has helped retain a lot of contributors over the long run, but that's another topic for another day. And then simplify getting started. So what is your process for getting started like? A lot of people make it so complicated. Like, I am just getting into your project. I don't think I want to learn how the terminologies, the very complex terminologies, how they work, or how the architecture on the ground was put together. I don't think I want to understand. I want to know, what is the community? Why does this community exist? What problem are we fixing? And how do I come in? Now, making me understand this, making me aware of this, making me more conscious of areas that I'm meant to, take responsibilities and work on. It's making me realize that, this is my responsibility for this project. Simplify the getting started process. If it means improving the documentation on how to get onboarded, improve it so that everyone that comes in that community is aware of this. You can always refer them to that particular documentation. And if it means educating the persons responsible for onboarding other persons in the community, then that should be a line of action that should be taken as soon as possible. And also adopt diverse methods of onboarding. Onboarding doesn't really have to do with, putting up a whole documentation that has all of that details. I got into one open source community sometime back, and I asked for the resources, the beginner-friendly resources to understand the project, and I was referred to the documentation. Now, on a normal circumstance, the documentation was meant to solve my problem, right? But I feel like documentation created more problems for me, because at the end of the day, I didn't understand the project. I didn't know what the community was all about. I didn't know where to come in. I just had a documentation that has so much information. And so try other diverse means of onboarding people. Other than sharing out your documentation, try having one-on-one calls with your contributors. Now, this doesn't have to be an everyday thing, but at least once in a while, try to have a call with the newcomers in your community, or a one-on-one call, or create a recorded video that actually explains your community, its purpose, and the goal you're working towards, and the areas that the new contributor would need to excel in that particular community. A video goes a long way, and of course, a one-on-one call also goes a long way. And there are other different ways you can improve on the onboarding that doesn't have to do with distributing so many documentations and a lot of content. Most contributors end up not reading this documentation, and at the end of the day have more difficulties contributing to your community. And have a responsive onboarding team. When I say have a responsive onboarding team, I mean delegate people whose goal or whose interests are to make others feel comfortable in the community. There's several persons within your community that actually would appreciate this kind of responsibility. So delegate persons that are willing to handle the onboarding process within your community, and make sure that everyone that comes in receives the best intro or the best welcome that any person should receive. And then let this be a common practice that goes on for a long time. There always be a responsive team for onboarding, so people can easily refer to these people or reach out to the persons of contact. And of course, look out for the contributors' welfare. A lot of communities don't do this. I might just be a contributor bringing in code, but the little attention I get from a community does a whole difference towards how I view that particular community. Now, another experience with an open source community is I got into this community, and the founder of the community was the person who sent me a message, a direct message. Well, that was exciting for me because I didn't think I would get a message from the founder. And then, well, through the discussion, the founder asked my goals, my experiences, how do I think the community can help me, and all of that. And I answered accordingly. And I was referred to the best ways to actually use my skills. And that was a very beautiful experience for me. So caring about the little efforts, about caring about these other persons that are coming into your community. I also know a founder that is aware of every contributor that works into the community. I don't know how this is possible, but every contributor, this founder can identify the contributors by name and by experience. And that's to show you that he cares not only about the code that you're bringing or the efforts that you're making towards the community, but he cares that you're going to learn while also making useful contributions as well. And so be kind with the review and feedback that you're giving out to your contributors. So while you're trying to get people onboarded and you've put together, let's say you've put together an onboarding process for your community and it's working perfectly. Now, after these contributors make contributions, either to your documentation or to your code and all of that, how kind and detailed are the review you give back. Some reviews are heartbreaking, and for someone who has very little or no confidence in what they're doing at the time, giving a harsh review would only serve as a blocker. And so be kind with your reviews that you're giving out. And another thing is take note of the documentation. If you're going to use your documentation as an onboarding tool, then your documentation should be as inclusive and informative, but then useful. Not so much information, but then not too little information. And try not to overwhelm your contributors with so much details, because a lot of persons get frightened by this. Try not to overwhelm people with so much details. Give very just the minimum details that they need to understand what is meant, what the problem is, what is meant to be done, and how they come in. That is enough to get someone motivated to bring in their skills and expertise. And of course, let's look at some of the rewards from quality onboarding for both the community and the contributors and open source at large. But it comes to several benefits. Now, this is one thing I've experienced from communities that I've contributed to and helped a lot of persons on board. Well, you're going to, first of all, see that the community will have contributor retention. I've tried this on layer 5, a community I've been contributing to for quite some time. And we've had the onboarding call for the past 1 year. And the contributors, most of the contributors come back to become maintainers. Most of the contributors come back to become interns in the community. Most of them come back, go out there and, advocate for the community and say, I joined this community and I got the best experience as a contributor. I was properly onboarded. I received the best welcome. Everyone was nice and friendly to me. Those are the kind of remarks we receive from contributors within layer 5. Now, this is because we put so much effort to making sure that if you're in our community, you're getting the best, not only from the leaders in this community, but then from every single contributor. If you're reaching out to a contributor, they're putting you and your needs first while working or making their own contributions as well. And of course, we have this decreased stress. As a maintainer or a leader in that particular project, you don't have to, break your head, have a lot of problems trying to control your contributors and get them to act in order, because all of that was taken care of during the onboarding process. So you don't have to, reach out to people and block or restrict or ban people from your community anymore, because that is strictly written in the code of conduct, which a lot of attention has been drawn to by the during the onboarding process. And so most of the struggles you explain from people asking the most basic questions about your community, the onboarding already took care of that. So now you have to, proceed to the next step, which is giving them tasks or bringing up ideas and all of that. But then you skip past the stress level where you have to hand feed your contributors. And of course, you gain the contributors' trust. For every community that I have contributed to, that I received the best welcome or a warm welcome, I made sure that I advocated for these communities in the best ways that I can. And I know I joined the Genome Foundation as a contributor. That was in my early days of open source contributions, but I tried to do a lot of advocacy for the community because I received the best experience during my stay in or during my contribution. And same for Chaos, and then same goes for Layer 5 and Apache API 6. And these communities put in so much effort to making sure that as a contributor, you're not just pushed aside or ignored while making your contribution, but you're welcome. And that made me comfortable. That made me realize this is a safe place. I can expand and explore. I can bring in innovative ideas on how to improve the project, how to improve myself, and how the community at large can grow. Increase productivity. Of course, when you gain the trust of people and they're willing to actually do this voluntarily, just like it expected, not calling every single person or compelling them to fix tasks, you're going to have an increased productivity and, of course, dedication from both the community and the community members and the maintainers and leaders in that particular community, because everyone is on the same energy. Let me use it that way. The energy in that community is on the same level where everyone is working together. And then we also have higher engagement and satisfaction. Higher engagements from the community members. You see people coming to ask questions. You see people answering those questions accordingly, even without the maintainers being there. And that is because they receive the proper information. And like I said, onboarding is like walking into university for the first time. Getting into open source is the same experience. Whatever information you give me on the first day is the same information I'm going to pass down to the other contributors getting into the community. And so when you give me information that it's not correct or not the best, I'm going to pass that down to other contributors, and I see how that affects the entire chain within that community. And so, but when a community focuses on onboarding, you see higher engagement because people are properly informed. People receive the knowledge that is expected of them, and they're going to, share this knowledge out. And for users, you're going to see users that are satisfied with the product that they receive. They're satisfied with the experience of using your product, and they most likely refer your product to another person. So that's exactly how the chain works. And then we have diversity in members, because you were open and not generalizing during your onboarding phase. A lot of persons felt this was a safe place to stay behind. And you're going to see diverse members coming with their, diverse ideas and perspectives. And all of this come together to build your project and give you a sustainable community. A community that is going to keep having contributors, that are going to build in more contributors, that are going to be educating and informing more persons coming in. And that is exactly how the chain goes. Now, from my experiences trying to help or contribute to open source communities, particularly onboarding, I've seen the growth of most projects rise from the bare minimum to the best, or the experience ranks it up, because we focus so much attention on onboarding, making sure that the newcomers receive the best treatment. And so you'll see most communities today, they have so many stars. Like you see in this picture, you'll see some people have a lot of stars for their project. And if you check their Slack channel or their meeting platforms, you're going to see lots of members, 2,000, 3,000, 5,000, 6,000 and thereabout. But the engagements for that community is not really encouraging. You see, the last message that was sent was 1 week, 2 weeks ago. How can an active community have one message in an entire 2 weeks? Does that mean the newcomers are not asking questions? Does that mean the users are not curious about the product? Or does that mean that people have asked questions and didn't receive answers, so they stopped asking? Well, these are the questions you actually have to ask yourself as a community leader or as a community owner. And of course, you look at the right, you're going to see the difference that we experience in these communities. You see that there are going to be more issues coming from the community members, more interactions in the Slack channels, of course, awareness for the project and all of that. Well, that brings us to the end of today's section, and I'd like to give a wrap and say thank you for listening during the section. I hope you picked a thing or two about how to improve your onboarding experience for open source community. And I'd like to give a word, just a word or a phrase rather. Like I said, onboarding is getting into open source community is like getting into the university for the first time. Whatever experience I get on my first day is going to last throughout my stay in that community. Whatever experience I get through my first period of being in that community will last for a long time. And so communities should focus so much attention on making sure the first experience or the first impression their contributors receive say a lot about the project in the best ways possible, and as well as the culture of that particular community. And so Thank you for your time, and yeah, that's all.
Thank you so much, Anita. You know something? When you know a talk is supreme, when you know it's elite levels, is when you listen to it and it compels you to start thinking about some of your own work and some of the things you're doing in life and how you might adapt, change, grow, and evolve. And listening to this talk as someone who contributes to open source, as someone who maintains some open source Terraform modules, you completely made me rethink the experience that I want to deliver to other potential contributors that may want to come and help maintain some of the things that I have built. So yeah, this is fantastic. Thank you so much. Anita, you are a great speaker. This is the second year in a row you've given a fantastic talk. There's been a lot of activity in the chat, so clearly the people are loving it. There's some comments from one of our speakers that's coming on a bit later on, Guy, that I can definitely relate to about experiences when you try to contribute to an open source project. And actually, this is a topic that came up on a Twitter space, which I do Twitter spaces for African software engineers every Monday. And we had a session a couple of weeks ago where we were discussing these types of challenges. So it's really fantastic to see someone with such vast experience unpack this whole thing and just present it to us in really easy to digest steps. So thank you so much. Before we move on, I just want to quickly shout out some of the people that are tweeting. We have Dev Neela popped out a tweet just bigging up the first talk. Neela said, "What a way to start the Tuesday. Terraform and Atlantis, such a combo move." Thanks to Urbina for the amazing talk on better developer workflow in infrastructure. So keep the tweets coming, keep the chat active. It's really appreciated. I'm really loving the vibe that we're creating. This is what we call community. Right. So segueing from Anita's talk, this is actually the perfect follow-up for Anita's talk. Anita's talked about how to contribute to open source and how you can, create a better onboarding experience for that. And this one, it feels like a bit of an extension for that. I have the absolute pleasure of introducing Ileri, who's going to give us a talk about getting started with infrastructure as code by contributing to Terraform Examples. This is going to be fantastic. And I think we can take some of the things we've learned from Anita's talk and take it a step further with this talk. So really excited to hear this. So Ileri, take it away.
Thank you for having me on this talk. I'm really glad to be here. And I think it's just the perfect combination. Like we had Terraform with Atlantis, then we had contributing to open source and onboarding in open source, and then we have this talk. So I hope everyone will really enjoy this. Yep. So Ileri Ayoadebi, for short, you can call me Ileri. I'm a cloud native engineer at Container Solutions. I'm also co-organizer of Kubernetes Community Days Africa. I started something to help people learn Kubernetes. So like I teach people Kubernetes, and I'm also the creator and lead maintainer of Markdown badges. It's an OSS project, an open source project. So I'm going to be talking about infrastructure as code and how you can get started, by contributing to Terraform examples. But the first thing is, what is infrastructure? All right, so I'll use my experience as an example. So I finished from the university. I studied computer science, and all I knew how to do was write some code on my computer. And over the years, I had not really done much work. I had not done any super work. All right, I was always just watching YouTube and writing code on my computer. But then I needed to get a job and I needed to understand how things worked. So I moved into software development, from IT support to software development at my workspace at the time. And I still wanted to understand how the software would move from my computer. How does software work in real life? Like, I can't just have it on my local host. Like, I wanted to understand the entire process. All right. So then I began to learn about infrastructure. All right. It made more sense because what I had known at that time was just a piece of software on my computer, nothing else. But then when you think about infrastructure, traditionally, what comes to mind is, things like power lines, things like roads, railway system, waterways, bridges, constructions. When you think about infrastructure in an economy, this is what you would typically think about. And yeah, so infrastructure is some of all these things that help economies, all right, develop. All right. Now, infrastructure is the basic physical and organizational structures and facilities, e.g., buildings, roads, power supplies, that are needed for the operation of a society or an enterprise. Now, how does this come into play for software? All right. I said I was just a software developer. I was just writing code. I knew nothing else. So think about Facebook, think about Netflix. All right, these things are softwares. All right, you go to facebook.com, it's a piece of code somewhere. Think of Netflix, you go to Netflix and you're seeing movies. Now, all of these softwares are, they're successful today. However, there are underlying things that make them, work as they work. The developers write their software and the software begins to live somewhere else apart from their computer. So now infrastructure is all software and hardware that supports software applications. So when you think of Facebook, you're thinking of facebook.com. Now, under facebook.com, there is network, there is database, there is DNS configurations. There's a whole lot of things. There are servers, there are computers, there are storage. So all of these things refer to is what we refer to as infrastructure. So it includes data centers, it includes your operating systems, deployment pipelines, config management, and any system or any software that supports the life cycle of applications. That's what we call infrastructure. So today, modern infrastructure can be created or destroyed using APIs. Now, let me break that a little bit. All right, you can see the cloud icon just beside there. With the advent of the cloud, or traditionally, okay, when people write software, we have operations teams that will take that software, they'll probably procure a server. All right, they'll wait for the server to get to their office after months or weeks, and they'll configure that server, all right, in their data center and do all of the networking, crimp cables, plug the cables into the server, ensure that there is cooling systems for the server, and all of those things. Traditionally, that's how things worked. But, as the cloud came, now the cloud gives us an opportunity to do these same things, but using APIs. Now you can connect to, for instance, AWS. You can go to aws.com and you're looking at a graphical interface, of course, that is powered by an API that you can now interact with to create a server, to create a database, seamlessly. So this is what the cloud gives us. And now when you have APIs under the hood, APIs that helps you to create infrastructure, then you can now begin to talk about infrastructure as code. All right, you can now begin to write code to manage infrastructure, because that's what APIs, would help you with. So I'm going to be introducing Terraform examples. So I figured that I shouldn't necessarily, because there was a talk on Terraform earlier on and we saw a lot of things. So I didn't want to duplicate that talk. So I'm just going to go straight to Terraform examples. So what is Terraform examples? Now, of course, Terraform examples is built upon Terraform. Terraform is a tool that helps you create infrastructure, all right, and automate infrastructure, provisioning. So Terraform examples is one project that we began at Container Solutions, and it was just to have examples of, how do I, for instance, create an EC2 instance on AWS, or how do I create a virtual machine on Azure, or how do I create a droplet on DigitalOcean, using code. All right, and so Terraform examples is a repository that contains several examples of all of these things. So you think of an example that I want to quickly deploy. I have an application or a software, and I want to deploy this software on DigitalOcean or on Azure. How do I go about it? Without stressing, I just need code to do that. That's what Terraform examples provides you with. So now, just some sneak peek. We'll look at that. We'll look at this in the demo. But in the Terraform examples repository, we have, if you look at this, it says provider, then resource type, example, then main.tf. That's the code structure. That's the way we arrange the folders. Now, provider refers to the, for instance, AWS or the Azure or the GCP or the DigitalOcean or whatever cloud provider you're using. That's what provider refers to. So this is the folder structure that we set up. Then you have the resource type. All right, what resource do you want to create on AWS? What resource do you want to create on Azure? What resource do you want to create on any other cloud platform? That's what you have as the next folder. Then you now have another folder. All right, I put example here, but it's just anything. All right, it can be a simple example. It can be an example of creating a database, an example of how to create cloud functions or what have you. Then, but the most important file there, all right, for people that would want to have a look at this is the main.tf. Now, if you're not too familiar with Terraform, right? Terraform is, like I explained, is a tool to create infrastructure. However, you write your infrastructure in a language called HashiCorp language, all right, HCL, and this is the way it looks. So we have this in our main.tf file. We have a summary of what that file is about. All right, that's what this shows you first of all. Then you have documentation, tied to every piece of code there. So you want to, you're looking at, for instance, you're looking at this third line or the fourth line that says Terraform required version, and you want to understand what this is. You can just go to that URL that is specified in the documentation, and you have the next set of lines like that as well. So that's what it looks like. So I'm going to be doing a demo, of this in about a minute. All right, but the first thing you need to do is you need to set up a cloud environment. You need to set up Azure, you need to set up GCP, AWS, DigitalOcean, any cloud environment that you have. That's the first thing. Then the second thing is you install Terraform. All right. When you go to Terraform's website, terraform.io/downloads, you see the instructions on how to install Terraform. All right. Then you clone this repository. All right. It's located at that URL. I just put the shortened URL there, but it's a GitHub repository and it's public. So you clone that repository, then you go into the directory. For instance, if you want to see something that has to do with GCP, you go into the Google directory, then you go into whatever example you need. And yeah, so these are the piece of commands that you can run, all right, to just try out these examples. So you have Terraform init, Terraform validate, Terraform plan, Terraform apply, and destroy. So I'm just going to be doing a quick demo. Hopefully the demo gods are on my side. Yep, I think I'm sharing. Okay. For some reason, I'm unable to share my screen.
Sorry about that. We're having a few technical difficulties. We will try and get Ileri back as soon as possible. But just to kind of recap on where we got to on the talk, I think it's really powerful to kind of see how you can use contributing to examples as a way of learning. I was always told that the best way of learning is to teach. So as you learn something, you teach. And sometimes when you do these things here, it fills the gaps in your knowledge because, the people you're teaching will start to ask a lot of questions that maybe you hadn't considered before. So this idea of contributing to Terraform examples is definitely a fantastic idea. We seem to have Ileri back, so we are going to bring him back on air.
Okay, cool. Yeah, sorry about that. So for some reason I was unable to share my screen, but I think it's looking good now. So I'm just going to show us what Terraform repo looks like, Terraform examples repository looks like. So I've already cloned, I've gone through the first step, I've cloned that repository. Now I said the first thing to do is look for your provider. What provider are you trying to contribute to, or are you trying to understand how things work underneath the hood? So I'm just going to pick Google, all right? And now there are several examples here. Of course, we still need people to contribute so that we can have more of these examples. But now you have, for instance, you have Cloud Functions, you have Cloud Run Service. So these are several resources that you can create, all right, with Terraform on Google, on GCP. So when you go into the Google Cloud Functions and the simple example, this is just a simple cloud function. Now, I said the most important file to have a look at is the main.tf, right? So this is where I'm at. And now I have this main.tf file. So if you, 1 second. So if you look at this code structure that I put up here, all right, we said we have the summary, we have the documentation of all of these things. That's what we have here. So we just took this and put it in this slide. And so first thing is I have this Terraform block defined. It tells me, what version of provider, what version of the cloud provider I want to have, running. You can have a look at this in the documentation, which is specified up there. Then we now have resources. All right. First of all, I have this variable, arguments here. There's a documentation there to understand what it means. But what this variable, just helps me specify is my project ID. So I don't want to, because various people would come and contribute to Terraform examples. Now, originally there was something here, which is this. So you're supposed to just change this project ID and put your own ID. All right. So I'm just going to put that back. So this is my ID for my Google project. Then you have the provider where we specify the zone, the region where we want, this resource to be provisioned. And we're using US Central. So we have some other information because this is a cloud function. So many of these things, you have to understand the cloud first of all. You have to understand what service you want to use on the cloud. All right. So if you're familiar with cloud functions, you know that you want to deploy a piece of software, a piece of code. All right, just a simple code, and that's what this data is actually referring to. So if you look at this file, it's a Python file, a very simple hello world Python file. All right. Then we have some other information there, resource, all right? But if you're a beginner, you may not need to worry about this. If you're a software developer and you just want to deploy your piece of software, you can just go over this and replace as needed. For instance, you replace this Hello World app with your own app, then you would link those things appropriately in this file. Then what we do next is, so I'm just going to bring out my terminal. And remember, I said the things you need to be bothered about, the commands you need to be bothered about is Terraform init, Terraform validate, Terraform plan, Terraform apply, and destroy. So Terraform init downloads the provider. For instance, we specified in this file that our provider is Google, all right? So Terraform init, I'm just going to run that. It downloads that provider, all right, onto your computer. So just give it a few seconds there. Yep, so that's okay. It means things are working fine. The provider existence has been downloaded. So Terraform validate helps you check if your file, is actually okay, if your configuration file is okay. So I'm just going to run that Terraform validate. Yeah, it says the configuration is valid. Okay, then the next thing is Terraform Plan. So Terraform Plan shows you like the plan of what this config is supposed to do. All right, it shows you what is going to happen when you eventually decide to create the infrastructure. So I'm just going to clear my screen here and do Terraform Plan. Yep. So if you have a look at this from the top, 1 second there. Yeah. Terraform Plan. So it tells me that it's going to create a function called change me function. Of course, you have to change where you see all these change me functions. It's just, where we have the things that we have put in place so that you can remember to change all of this information, to something that works better for you. So it's going to create this other resource. It's going to create this storage bucket. It's going to create, it's going to do a lot of things under the hood for us. And this works because of the API from Google that has been exposed, and Terraform connects with that API. So I'm fine with this. It tells me that there are 5 things that are going to be added, to my Google Cloud account, and there is nothing to be destroyed. So since I'm good with all of this, then I can just do Terraform apply. So I'll do Terraform apply. Terraform apply will show me a plan just to be sure that I'm fine with this. But because we've already checked the plan and we're fine with this, so we can just hit yes to continue. So when I do this, yeah, it will take about a minute for this to come up, all right, because it's provisioning some things underneath the hood. But I'll just quickly go over, the repository and show you what it looks like. So like I said earlier, we have various providers. We have the Kubernetes provider, Linode, we have DigitalOcean, like I mentioned earlier on. We have Azure, AWS, and a lot of providers that you can just have a look at. Since if you're getting started with Terraform and you just want to see how things work, I want to test a service on this cloud provider. And yeah, so when you do all of this, it begins to provision the infrastructure on your cloud account. All right. But if you're going to be contributing to Terraform examples, now you're still going to follow this process. All right. But you now have to make pull requests. So let me just move forward. Yeah. So this is the code structure, like I explained earlier on. All right. Is what we've seen in the code. Then there is a CI pipeline. So when anybody pushes code to Terraform examples repository, we run all of these checks. We lint the code, we check, if it's formatted properly. We do a TF validate, all right, Terraform validate. We run some checks, we also run some checks on the provider to ensure that things are, working as they should. And yep, so let's just quickly check that. Okay, so this is done creating. So it tells me that apply complete 5 resources added. So I'm just going to go over to my Google Cloud platform. Yep. 1 second there. Okay, I think I got it opened here. Yep. So I'm going to go over to my Google Cloud platform. And yep, so this is my cloud functions, dashboard. And it shows me that this, function has been created. That's just with code. All right. I have code written for this. Now, the beauty about infrastructure as code is that I can always be sure of how my infrastructure looks. All right. Because I have defined it in code already. Then whenever for instance, a lot of people who are getting started in cloud, they always complain about the costs because they don't manage the infrastructure properly. So one of the things I can do is I can tear down this infrastructure just with code, and I can recreate it whenever I need it, again. And so this is the cloud function that I just created with Terraform. So if I go to trigger, I can just look at the URL, and when I click on that, yeah, that's the Python app, hello world, right? And this was done with Terraform. So you can check this into a repository, you can set up pipelines on it, and begin to have infrastructure, automatically created, automatically provisioned using code. All right, so I'm just one other thing to make sure you do not forget is, so I'm just going to start sharing again. Yeah, don't forget this Terraform destroy command. Now it's if you create infrastructure and you're not using it anymore, it's just good to stop and just tear down that infrastructure. So that's what Terraform destroy does for you. So because I do not want to have I don't want to just run my account low, so I'm just going to destroy this infrastructure, this piece of infrastructure. Yep, so it asks me that all of these things will be destroyed, 5 things that was created earlier. So I'm going to go and say yes. So in about a few seconds, this will be done. All right, so whilst that is still ongoing, yep, so this is the CI like I explained. So we would love you to try out Terraform examples. We would love to see how, help you get involved with infrastructure as code. I know a lot of people have reached out to say they want to learn DevOps, and this is one of the tools in the DevOps ecosystem that you can get your hands on and learn. So we'd love your feedback, and thank you for having me. So we're hiring. If you want to join us, please feel free. Thank you so much.
Thank you so much, Larry. Fantastic talk. Loving the way that even when the streaming gods were against us, you were able to roll with that. So big congratulations to you for delivering such a fantastic talk, even with the adversity there. Yeah, I think I gave some thoughts earlier on in the intermission, and I'm just going to echo that. I think it's a very good idea to contribute to something like this if as a way of learning. Essentially what you're doing is you're teaching as a mechanism for learning. So I really do like this approach. Now, before we move on, let's just do a bit of a stroll in the chat and on social media. We are actually streaming to two places. We're actually on the YouTube, as a lot of you are, but we also have quite a lot of representation on LinkedIn. And I've just got to say, it's really fantastic to have so many people from all across the world and all over Africa joining us today to partake in such a wonderful event. We've got representation from Mozambique, Angola, Zimbabwe, South Africa, Nigeria, Ghana, the list goes on, Pakistan, Iran. There's so many different countries where people are tuned in from. So thank you to you all. Now, the tweet I'm going to highlight from this round is from Nas Codes, right? And Nas was talking about Anita's talk just before, and has put a screenshot in of the chat. And if you recall in that talk, Anita said that she loves cats, and the joke of that talk there was someone saying, is it cat 7 or is it cat 6? Personally, I thought it was cat 8, but let me know. Right, so we have our next speaker, who again is a returning speaker. Again, very excited to introduce to you Victory Brown. Like we say, we had Victory last year. Very happy to have her back. This one's a little bit different. We're doing a bit of a lightning talk here. So this is going to be kind of short and to the point. So it'd be great to kind of get your feedback and let us know how you feel about these ones here. But excited to introduce Victory to the stage. So take it away, Victory.
Well, hi. My name is Victory Brown, and I'm very delighted to be here again as a speaker at HashiTalks Africa 2022. Today we're going to be talking more about, so let me introduce myself, sorry. My name is Victory Brown, and I'm an open source advocate, a content writer for Web3, and I'm also on the advisory board for DrupalCon Prague 2022. I'm very excited to be here. Well, today we're going to talk about building an inclusive developer environment. I'm going to talk about how organizations could build an inclusive developer environment and how developers could identify inclusive developer environments. First, we have to talk about what inclusion is. Inclusion is including everybody, despite demography, belief. It doesn't really matter, but to an organizational level, it goes far beyond that. Inclusion means being open to different thoughts, different working patterns, different people, different cultures, and how all of this could work together to build a very good and usable product. Now let's talk about developer environments. A developer environment is a workspace for developers to make changes without breaking anything in a live environment. So it's like a playground where developers go and they contribute, collaborate, and interact with one another on a product development process without actually working on without actually destroying the real projects. Developer experience describes the experiences developers have while they are working or while they are using your product. I know we talk about user experience a lot, but in this angle, we're going to be looking at the users as developers. So developers
using softwares, using different frameworks, using different developer environments to build products for users. So we're talking about that particular experience that developers have. Next, we've talked about developer environments. So how can organizations create good developer experiences? First, fitting architecture. This has to do with the structure of the organization. So if an organization has a fitting structure where there is hierarchy and developers have who they would refer back to for feedback and communication can easily take place seamlessly, it's said to say that that particular organization has a fitting architecture. Next, we have great tools, great working environments, easy to learn framework, and also like a proper documentation process for these developers. That way you create a good developer experience as developers work in your organizations to build products. Next, we have a non-toxic team culture. So in an organization, in an environment where team members are free to interact with one another, there's no hostility, and as much as members work independently, they could easily work together. That can also help to build a good developer experience. Now, how could developers identify organizations or cultures that depict bad developer experience? We have finger pointing. So if you're in a community or in a team where there's a lot of finger pointing and name calling and blames, it doesn't really give off a good experience. So there could be conflicts, but when the conflicts moves to finger pointing and blames and it goes on all the time, that actually shows that's a red flag for that organization or for that particular team. Next, we have constant overloading of teams. This happens a lot where the organization does not have a proper or an outline structure of hierarchy for developers to give feedback to. Then we have diluted responsibilities, can also be caused by lack of structure, lack of accountability and responsibility for team members and team leads. So how could organizations make developer environments more diverse and inclusive? How could they do this? One of the ways that organizations can make the developer experience more diverse and inclusive for developer environments is by hiring from a diverse community. So we have diversity job boards that are inclusive to the Black community, minority, women, and all of that. Organizations could go to these job boards and recruit diverse employees for their organization. Next, they can provide targeted internships to these organizations or to these spaces where it is more diverse. There's like a pool of diversity of talent and all of that. So organizations could create hackathons, challenges for these communities. I could use it for a way to outsource talents from these diverse communities that could be onboarded into their community. Then we have build diversity and inclusion into the culture and value of the organization. So when diversity and inclusion is built into the culture of your organization, when new employees come into your organization, they are aware of this, and it is kind of like introduced into their system. So when they come in, they have to work in that pattern because it is written in their code of conduct, it's written in the employee workbook, and everybody in the organization is well aware of this. So it is very important that developers are, in conclusion, it is very important that developers are put in an environment where it is healthy and conducive enough for them to work. And when I say developers, I do not just mean programmers. I'm talking about the full team, the whole organization. You have to make the environment where this product is being built to be a very healthy one, because there are humans working on it. And sometimes being in an environment where you experience poorly, or is being experienced poorly, could lead to low production in work, and low production could lead to low outcome, and eventually it could also be a loss on the company side. So organizations should focus more on building a healthy and diverse developer environment for all. I'm going to leave it a quote. It says, yesterday is history, tomorrow is a mystery, and today is a gift. This is why we call it the present. Well, thank you for listening. You could connect with me on all social medias at Victory Brown, and I would love to hear your questions. I will be in the waiting room to answer your questions, any question you'd have based on this session. It was nice talking to everybody here. See you all soon again.
Thank you so much, Victory, for delivering our first ever lightning talk, actually, on HashiTalks Africa. So you've actually made history there. So be proud of yourself. Thanks so much for that. Just want to shout out one of my boys from Takoradi, Ghana. So everyone knows my parents are from Ghana. My parents actually have a house in Takoradi, which is where this person I'm shouting out is from. My brother Rexford, Tidy Boys, thank you so much for joining us. He actually joined us in the YouTube and now has jumped over to the LinkedIn. So I just wanted to shout you out. Fantastic having so much representation once again, especially from my home country. So I love that. We have a fantastic talk next up, but before we go to that, we are going to take a short 10-minute break. So go and stretch your legs, go and get a glass of water or a hot drink, a beverage of your choice, and relax. And we will be back in around about 10 minutes. So I'll see you then. So, welcome back after a short break. It's been a fantastic start to the event so far. And thank you for those that are hanging around and staying with us for the rest of the event. I really appreciate that. I have the absolute pleasure of introducing our next speaker, who is going to show us a Waypoint talk. This is actually the first time we've had a Waypoint talk. Waypoint is one of the newer open source projects that HashiCorp has launched. So it's my pleasure to introduce to you all Abdurrahim, who's going to show us about Waypoint. So over to you.
Hello guys, thank you Rob for introducing me. Well, today we will talk about Waypoint. As you said, it's a new project for HashiCorp, and it's a very powerful tool for developers. Okay, let's start. And my name is Abdurrahim Subaili. I'm from Morocco. I work as a software cloud guy at Optimize. Work mainly in telecommunication and payment services, and I'm very interested in cloud and distributed system. And today talks is about your point to Waypoint. I'm not here actually to teach you something, but I'm very fascinated by how Waypoint is easy and powerful, and I'm trying to show you that. So let's begin. Every application has a lot of phases or life cycles, and it starts like a line of code in your favorite code editor or IDE. It's mainly now we know that Visual Studio Code is the de facto standard of this, and everyone is using it. After that, you should write some tests using your favorite frameworks or tool. We are using Selenium as a de facto standard tool for this one. After that, we should build our application to generate some artifacts. Those artifacts will be deployed and released somewhere, and will be operated by Nomad or Kubernetes or something like this. As you can see, we have 3 green circles. I mean here by green, like we are mastering this phases, and there is tools that there are standards for this, but for build, deploy, and release, we are hacking around to make those phases automatic and reliable if it's true. So our bottleneck is these 3 phases: build, deploy, and release. Why? Because there's a lack of standards. Everyone is doing his stuff by his own. We have a lot of, for example, we have a lot of artifacts to generate depending on the platform that we want to deploy to. For example, if you want to deploy to a Kubernetes, you need something like container to do that. If you want to deploy to some serverless platform like AWS Lambda or something like this, you need to write code in certain format and build for some specific target to do that and do so. So there is a lot of platform that make it hard for the developer to easily choose one tool to do all the stuff. And we generally create our bash scripting for that. Generally we use hacking around like putting our scripts in some pipelines in CI/CD or something like this. So and for release, it's the same. For release, releasing here is like more traffic management. For example, if you want to do something like canary deployment or blue-green or stuff like this, it's hard to do it like with tool that we have now. So here it's come a bunch. It's give us a very easy to use and consistent workflow. So we will mainly create one single file, one checkpoint for our project that will englobe these three phases: build, deploy, and release. And of course, we can deploy and release to multiple platforms with single file. It's give us the confidence. Every developer that's deployed to some platform, it needs some visuals, logs, an URL for testing his release or his deployment version or something like this. So Waypoint give us this visual very easy, and is give us tools to check logs and go check our deployment in real time. The other stuff, it's very extensible, so everything in Waypoint is extensible. Platforms, builds, deploys, you just use built-in plugin by the team, or you create your own plugins and you deploy to your favorite platform or build with your favorite artifacts tool. Okay, the global architecture for Waypoint is something like this. We have CLI and the UI platform. It's like a PaaS experience. PaaS is stands for Platform as a Service, and this PaaS or this platform is give us all stuff that CLI give us too. So you have the choice to use the CLI, the command line interface, or you use the platform. So this is the client of our architecture, and we need a server somewhere to serve the Waypoint APIs. So think about it like some a control plan for a server mesh and data plan. The control plan is the mind of our system, or the brain of our system, and it's communicate with the data plan. The data plan is the deployment or the VMs or the stuff that we are deployed on our own. And as you see here, we have something like entry point. Think about it like a sidecar injection here for like a service mesh. For example, if you are familiar with Linkerd or ASTO, it's the same thing. And this entry point is injected directly by the build phase, and it's built in by the Waypoint team, and use us and helps us to provide logs, to provide an URL, and to communicate between the server and our deployment on our favorite platform. There is a missing point here. It's not missing, but it's like a hidden part here is a runner. The CLI is scheduling a build, for example, or deployment, and the runner is doing the job. The runner mainly is, you can think about it like runner in CI/CD platform, for example. It does all the job. It can be a local runner, so in your local machine or something like this, or it can be a remote one. Same thing for the server. It can be for in your local machine or remotely. And of course, a single server can or a single CLI can talk to multiple servers. For example, if you have a server for production, server for the staging, something like this, same CLI can talk to all these servers. Okay. Okay, let's move to configuration. The configuration is pretty easy and pretty standard. Like we used to have the HashiCorp language. It's like an easy file with 3 phases here, or 3 block of codes. Every block of code is represent a a phase of our application lifecycle. For example, here we have built, we are just using built-in plugins called pack to build the application, and it will generate an image. This image, it will be pushed to a registry, a public registry here in Docker Hub, and after that I will deploy this image in Kubernetes. So I will just use again plugin and with some parameters, and I will release in Kubernetes. Of course, I can deploy and release in different platform as I want. We'll see that. So the power of this file or the waypoint is give us a one single file that's englobe all this stuff, all our workflow. It will be a code, and we can manage it in our version code. For example, it's give us the end-to-end experience from the build to the release. Okay. The build and deploy, it's pretty easy, as we used to use our HashiCorp products. We just up stuff. So I waypoint up my configuration file, and the magic is there, and I will just wait for 5 minutes or less, depending on your build and deployment tool, and you will get some visuals and URLs to check your code and logs and stuff like this. And of course, you can use the CLI or waypoint app, or you can integrate waypoint to your favorite Git operation. For example, you can integrate it to GitHub Actions or stuff like this. So it's easily integrable into a CI/CD pipeline. Okay, let's move now to the GUI part. The UI part is like the client or our visual, and your team can go to one place to for example, check all the builds, check all the deployment that you did, the versions of the deployment too. We will see that in the example. And waypoint give us a very, very cool stuff like real-time monitoring. For example, we can get status of the application in real time, and we can get the versions like you can see here, the version and the time that the version of deployment and the time of deployment and the status. Of course, the platform here is Docker, and we can see all the deployments and logs in one single place. Okay, I will show you a demo. You can find the slides in my GitHub, so you can just clone the projects and play with it. It's pretty easy. Okay, and here we go. I have two folders here at Docker and Kubernetes. Let's start with Docker one. Let's have nothing special, just an HTML file here. Docker is running, and a Docker file. It's an Nginx-based image with some simple configuration in here. Like you can see, it's just like when you deploy your React application or something like this. And we have a waypoint file. Waypoint configuration file here. It's have the project name, and it's have the application. The application here is named web. Hope you can see. I guess now it will be better. We have our application, and we have the first block, it represents the build phase, and second block, it represents the deploy block. Both of them use Docker as a plugin. So I will just do something like you can let's take a look at CLI first. You can install it in your machine, and you will get something like this, a command line interface, login, build, stuff like this. Other commands, you can, for example, get context. Like, for example, if I context list, we get the context. Context is like the server that the CLI will talk to. For now, we just talk to my local server deployed on Docker. And to install a server, you can install it on Kubernetes, on Nomad, on Docker, on any platform you want, and the CLI will help you. You just need to do something like waypoint install. You specify the platform and accept the tools, and everything will be deployed for you. And now let's, for example, go to the Docker project. First thing I need to do is to initiate the waypoint. So I tell waypoint to consider this as a project. So I just do something like init, and it will read the file and validate it. For example, if there is some issues in the file, it will pop it out in here and tell me there is something wrong. If not, it will just do something like this. And I will just need to do something like waypoint up, and it will start the build phase. For example, here you can see logs of building an image here using Docker, and it will deploy it to a container, or in this phase it will deploy it to Docker. So as you can see here, it's give us the logs, and as we don't have a release, it will not give us a release phase for this, but we can specify it. For example, we just need to do something like and as we are waiting, I will just start a Kubernetes cluster using Minikube. Let's check if we have something here. Yes, we have something already there. Let's watch for deployment. Okay, as you can see here, I can just do something like Docker PS, and I can see here my application up and running, and I can test it locally and stuff like this. We will do something like more exciting when we go to see the UI. The UI is something like this. The project is the same thing that I have in here. We Okay, it's web. Okay, I guess I have some issue somewhere, but no worries. It just give us a very beautiful visual, and I think we can see this with all of project. So and go to Kubernetes. Sorry. Go to Kubernetes 1 and just init. Let's check in here. Yes, it's a little bit slow, but it's here. We can see all the deployment I did with the logs in here. Releases to the platform, and I guess there is some issues. Yeah, there is the logs in here, and we have the phases that we have in the GitHub file, in the configuration file. And if I go there and I try to init the other projects, let's see the configuration file first. It's nothing, just some a very simple Go application that will show us hello waypoint, and the configuration file is pretty easy too. It's something like, I just need to remove this, and it's something like build using pack, so and push to the hello Go image and use Kubernetes to save the application. I will just save it and waypoint up for this. As you can see here, it's using pack to build the application, to build the Go application, and pack it as an image. And I guess I need to minikube channel. Okay, it's pushing now the image to a Docker Hub. After that, the deployment phase. It's automatically detect the ports in my application. Now it's creating the deployment on my Kubernetes. I guess I have something. Okay. I have some timed out stuff. But I guess if we just kubectl git deploy, we can see our application in here. Okay, I can just I guess there is some internet issues. That's why it's not deployed. But the essential is that we have one single file that's enveloped the three phases, and it's easy to switch from a phase to phase and to configure it every phase. For example, here for Kubernetes, we can configure how the number of replica, the probes of liveness and readness, and we can specify the ports that we want to be deployed to, and everything else. And we can use the CLI or just go to the UI and see what's happening. It's a little bit slow, but the essential is Waypoint is very, very promising project. It's now in version, I guess, 0.8, and it's under a heavy development. Every week you will get some new version, some new stuff, some cool stuff. For example, we have in the version 0.7 the integration with GitHub. So we just introduce something like a GitOps. You just push to your GitHub, and everything is running in Waypoint. And as you can see here, I have logs and stuff like this. Even if it's failed or stuff like this, I have logs, and I can check my phases, see where is my errors and stuff that doesn't work, and I will fix them and redeploy using Waypoint up. And that's it for my talk. Hope it's pretty clear for you. You can see it's a very powerful tool and very easy to use. Just one configuration file and 2-3 command line stuff. That's it, and thank you for having me.
Thank you so much, Abdurrahim. I really enjoyed that. And I think, like you say, Waypoint is a really promising open source project. I have so many workflows and ideas in my head that I would love to experiment. And, as a fan of HashiCorp tools and the way that we go about implementing some of these workflows, I really can't wait to see the direction that the tool heads in. So thank you once again. If you do have any questions for Abdurrahim, please drop them in the chat. Hopefully Abdurrahim will have the time to hang around and chat with you all. So let's move on to our next speaker, who is actually an AWS community builder, who's going to give us a talk that I'm really excited about, which is continuously well architected with Terraform, right? So I would like to welcome to the stage Iwere. Thank you so much, and looking forward to this talk. Take it away.
My name is Iwere. Thank you for the opportunity here, Rob. Today I'll be talking about continuously well architected with Terraform, basically. So let's go. I'm talking about continuously architected with Terraform, and it's it's going to be a very interesting topic for us. So let's go. Before we get in, let me just talk about myself a little bit. My name is Ewere Diagboya. I'm head of infrastructure at Indicina. Indicina is a fintech company in Lagos, Nigeria, where we do a lot of work around creditor system, where we help companies to decide who to give credit to. I'm also the author of Amazon CloudWatch book, which I'll be showing very soon. I'm also the first AWS community hero in Africa. I blog at Medium a lot. I write a lot of stuff on Medium about DevOps, about cloud computing. I also love music, art, and reading. I forgot to add that I'm a potential photographer at the moment, so it's something I picked up recently, and that's me. So let's go into the meat of the day. So this is my book on CloudWatch. You can get it. It's published by Packet. It's already at Amazon, and yeah, it just gives you information about CloudWatch, what you can use CloudWatch to do, the basics of monitoring, observability, and all you need to know about monitoring from the ground up. If you're a learner, you can actually get this and get it up and running. Okay. What does it mean to be well architected? I think that's the most basic question to start with. What does it mean to be well architected? Before now, I don't think this statement was much of a big deal. We used to deploy cloud resources based on a lot of assumptions, okay? We just get into the cloud, set up what we need to set up, and get things done. And what happened over time was many organizations fell into a lot of issues, such as security issues, such as scalability issues, such as reliability issues of their systems. And companies and businesses built a way of a structure, a standard within the organization of how to run these systems, okay? But hey, the well-architected system is supposed to be like a standard, okay, that we can all work with. A standard that helps to make everything work out perfectly fine in terms of architecture. So let's talk more about what does it mean to be well architected. So the well-architected framework is a set of building architectural principles to aid the setup of resilient, secure, and cost-effective cloud infrastructure. That's basically what the well-architected framework is about. So it's supposed to help us to build better architecture. Like I said, before the well-architected framework, companies and organizations used to build their infrastructure any way they like and just get things done and get moving. But those activities have their consequences, okay? So the well-architected framework is supposed to help in guiding principles, okay? So that we can set up and deploy resilient, secure, and cost-effective cloud infrastructure. So apart from just setting up the infrastructure, the cost of the infrastructure is also important. We have to know that there are better ways of setting up our infrastructure. There are better ways of architecting the systems so that they are more affordable. The next is, there are 5 pillars, and they were actually made this in reInvent 2021. I mean, actually not 2022. That was reInvent last year. Okay, so these are the pillars that make up the well-architected framework. We have the security pillar, we have the operational excellence, we have the performance efficiency, we have the reliability pillar, we have the cost optimization pillar, and the sustainability pillar. Now, these pillars are just the way they are mentioned. They are like title headings for the 6 areas where you can focus on when you are setting up and deploying your cloud infrastructure. So what these pillars are trying to say is that you need to find a way on how you can follow the structures of each of these patterns to ensure that you are able to deploy your infrastructure adequately. Now, each pillar has a set of rules for implementation. So if you go into the security pillar, there are certain rules that they give you to be able to deploy your workload properly. If you go to the operational excellence pillar, there are certain rules you are given to ensure that you deploy appropriately. Same with every other pillar in the well-architected framework. Now, the question now is, we talked about AWS well-architected framework, we talked about the pillars, and how these pillars are supposed to be guiding principles. But how does Terraform come into play? That's the question. It doesn't make any sense. I mean, we just talked about AWS and well-architected framework, and this presentation is talking about being continuously well-architected with Terraform. So where does Terraform come into play? So the simple answer is this. using Terraform alone already fulfills the major part of the operational excellence pillar. Okay, now what's one major part of the operational excellence pillar? It's a way of ensuring that you are able to use things like what we call infrastructure as code. Infrastructure as code helps you to define infrastructure more in a programmatic way than just going to the console to click and get things done. A very basic example, you want to set up an EC2 instance. Most times you need to think about the instance size in AWS, the size of the EBS volume, what VPC you want to configure that instance into, and so on and so forth. 90% of the time, if you're new to the cloud, you just go to the console and you go to EC2, launch an instance, click next, and boom, and you're done. Now, the problem with that is you will not be able to repeat that process exactly the way you did in the same way every time. And that's where infrastructure as code comes in. And apart from that, you also cannot transfer that information or that knowledge over to every member of your team, because most times you're working in a team, not just a single person. So it's good that you have a more defined method of how these things work. It's just like writing a story on a book. I mean, you can easily pick up a book today. You can pick up Rich Dad Poor Dad and learn the stories that Robert Kiyosaki wrote there. So what infrastructure as code is saying is we need to be able to document. We need to be able to write out how we want these things to work. It's just putting it in an English form, okay? Putting it in an English form so that everyone can put it in a written form, so that everyone else can actually use that particular thing. And that's where the operational excellence pillar talks about. It talks a lot about making sure infrastructure is repeatable, making sure the infrastructure is transferable, okay? And that's how Terraform already solves a part of that pillar for you. So we see how using Terraform alone already solves a very basic problem in terms of well-architected framework. So if you're an organization, you're using Terraform, you are a step ahead in terms of being well-architected. But if you don't use any form of infrastructure as code, and for example, Terraform, then you might have to think about that again so that you can use something that will help to scale your organization. Okay, then introduce Chekhov. We've talked about AWS, we've talked about well-architected framework, we've talked about Terraform, infrastructure as code that makes it possible for you to write your infrastructure how you want it to look like, okay? So you have a written form of your infrastructure where you can actually share this written form to thousands and millions of people all over the world, and you get the same output at the end of the day. But we're talking about trying to be well-architected, and don't forget that the well-architected framework has about 6 pillars, okay? About 6 pillars. So it means that we are trying to make sure that we are as well-architected as we can in every resource we create for something as basic as an S3 bucket, which is what I'm obviously going to show us in our demo, okay? Something as basic as an S3 bucket, there is actually a proper way to configure an S3 bucket in AWS. You know, you can just say, oh, it's just an S3 bucket, it's just to click on create bucket, type in up the bucket, and boom, you're done. Trust me, that bucket is not well architected. There are so many other things that should go with that bucket when you are creating that bucket. It's just easy to go to the console and click next, boom, 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 bam, finish, and you're done, and you move out, okay? So what you need to do is we need to find a way to make sure our S3 buckets are well architected. They follow guiding principles of the well architected framework, and that's where Chekhov comes in. Now, what is Chekhov? Now, Chekhov is a tool that checks to ensure that infrastructure as code is defined to be standard, okay, to certain standards. Now, Chekhov has hundreds of set of rules it uses to check the infrastructure as code for standards, and these rules can be customized to meet specific business needs. So Chekhov on its own is a tool for standardization. It helps to check your infrastructure as code to ensure that you are writing it according to certain standards. And one of the standards that it follows, it has hundreds of rules, okay? Chekhov is actually by Bridge Crew, okay? They have a paid version, they have a free version. So when you use Chekhov, it's able to check your code, okay? And tell you, you know what, you need to do this, you need to do that, you need to do this for your infrastructure to be better configured and better designed. And that's exactly what the well-architected framework is talking about. The well-architected framework is talking about ensuring you design a resilient, scalable, and cost-effective infrastructure in the cloud. And I mean, what best way to check it by using checkoff to make sure that you always continue to check your infrastructure code to make sure that it meets those standards. And the beautiful thing about checkoff is that it's CLI based, so it can easily be integrated to any CI tool, okay? From GitHub Actions to GitLab CI to Jenkins to Bitbucket CI to whatever CI tool you use, okay? I just mentioned a few of them here, but since it's a CLI command, you can basically integrate it to any CLI, a CI tool, CI/CD tool, to perform that continuous check. So whenever you check in code and you create a pull request, you can just create a trigger and checkoff to be able to check and make sure that that code that you are checking into trunk actually meets the standard of the well-architected framework based on what checkoff validates in that particular script. Okay, a little bit of demo time here. So let's look at a very simple code that I wrote, and let's see how we use checkoff to check it and see what checkoff flagged in that code to show that we whether we are well architected or not. Okay, so here we are with this Git repository, which has a very basic Terraform code. So I'll just quickly go to the Terraform code and explain what I did with checkoff. So basically, this is simple Terraform code that helps to create an S3 bucket. So I just went to the Terraform website, okay, the documentation, and picked a very simple S3 bucket creation. Okay, this is as basic as you can get an S3 bucket. I mean, if you want to create an S3 bucket, this is all you need, with all the right credentials and access key and secret key, whatever a method you want to use to authenticate and authorize your Terraform code, and it creates a bucket. But unfortunately, this bucket is not well architected. Okay, it's not following those 6 guiding principles of how you should deploy any resource in AWS cloud. So what else do we have here? We have the provider file, basically, which shows us the AWS region, the Terraform version, and all that. And then we've integrated GitHub Actions here, which is the whole subject of the conversation, which is about making us continuously well architected. So what the GitHub workflow does, basically, is that it continues to check to make sure that what we have is well architected. Okay, so let us see the action that we ran to see what it actually brought out, if we are actually well architected or not. Let's see if what I'm saying is actually right or wrong. So if we come to actions, we can see the workflow, and we can see they are all showing red. Okay, so let's open one up and let's see what the logs are saying. Okay, so there's a lot of interesting stuff going on here. Let's just go down quickly and get to the meat of the matter. Okay, so these are all debug information coming from the checkoff library. And when we get to the bottom of all this, you're going to see something very interesting. Okay, you're going to see that checkoff has different rules for checking your infrastructure. So I'll just digress a little bit here and you see Chekhov is running a check to ensure S3 bucket policy does not lock out all root users. So Chekhov is starting to run a check on my code, okay? It's running a check on the main.tf file, which I have given it as a directory where I have my file. So it's running a check and see if anything passes or fails. And part of the default rules it also has are rules for other environments. For example, you can see it has some rules for Azure right here, okay? But what we have is AWS, so it's going to do more for AWS. You can see it has some rules for Azure, AWS, and Google Cloud. So Chekhov is actually, it works for any kind of Terraform code, wherever you're deploying the Terraform code into. And when Chekhov was done, it came up with some very interesting results. 5 checks passed and 6 checks failed. So let's quickly look at these checks that failed. The first check that failed is a code they have. So this is like a Chekhov internal code for tagging every compliance error or any of that sort within their environment. So it says, ensure S3 bucket policy does not lock out all but root user. Okay, so it's trying to tell us here that we need to make sure that the S3 bucket does not lock out everyone. There's a way you can configure an S3 bucket policy that no one else can use that bucket. So Chekhov is trying to check your Terraform code to ensure that the configuration does not work in that way that it blocks everyone out. The next is trying to flag here is saying, ensure S3 bucket does not allow an action with any principal. So this is a security check that Chekhov has done for us, which is part of the security you will find when you check well architected on S3. Because the truth is, well architected framework applies to every single service within AWS. Okay, there is a holistic standard, but there are also specific standards for every single service. If you pick up an AWS service and you pick the 6 pillars, there are specific activities that you need to make sure that that particular service is well architected. Okay, so one of them here is saying that ensure that the bucket does not allow an action with any principal. Okay, if you look at if you use S3 a lot and you look at the policies for S3, what it's trying to say here is the principal should be a specific principal and not just any principal from your bucket policy configuration, which is very, very awesome. It means that you're making sure that that bucket is not accessible by everyone to perform any action they like, okay, which is one of the rules of security we call least privilege. Okay, it's part of the well-architected framework and the security pillar. The next we have here is ensure no hard-coded AWS access and secret keys exist in the provider. This is also part of the security pillar also. So you see, automatically, the fact that we're already using Terraform, we have fulfilled the performance, the operational excellence pillar. And now Chekhov is also helping us to become better well-architected by telling us security principles we should follow in terms of how we should secure our bucket. And now he's talking about AWS access key and secret key credentials that shouldn't be, okay? And then the next thing is ensure that the bucket policy allows only read and not write access, okay? The next thing we have here is ensure that S3 has cross-region replication. So, I mean, initially it looked so much like it was all about security, but here, this is not about security. This is about reliability. Don't forget, when we talked about the 6 pillars, we talked about reliability, performance efficiency, operational excellence, cost, security, and sustainability. So it's telling you that you need to ensure that you enable cross-region replication. What does cross-region replication mean? It means that your bucket is able to replicate itself across different regions for higher availability. So if anything happens to your data, you are sure that your data is automatically available in another region within AWS infrastructure. So you see how Chekhov works with Terraform to ensure that your AWS infrastructure is well architected. Now, what is so beautiful about using a CI tool or GitHub Actions in this scenario is if someone else decides to contribute to this code, creates a pull request and pushes the code, what is going to automatically happen is that it is going to check again, immediately the push is done. It's going to automatically check and say, is this code still well architected? Because it's a GitHub action that is triggered on push, it will run through that script. And if it fails based on the standards, it's going to show you an error that you are not well architected. And then you have to go back to your Terraform code, make the changes, make the suggestions, update it accordingly, and ensure that you are well architected. The next thing we have here is that ensure that the S3 bucket has access logging enabled. Now, we talked about operational excellence. Now, this is under performance efficiency. Performance efficiency has to do with how you manage your operations within your organizations. And one of the things that goes with managing your operations and your systems and understanding how they work is by logging activities. So what this is trying to say is we need to enable logging so that we can see everything that's going on within the bucket, data going in, data going out of the bucket, data being deleted from the bucket, how data is being accessed in the bucket. This logs makes it easier and better for us to operate more efficiently, understand what is going on with the bucket, and fine-tune the bucket to be more efficient. Let me give a very basic example. If we understand the access patterns of our bucket, we could actually change the storage class of the bucket to moving it from maybe a standard to what an intelligent tiering or even a glacier, because we have used the logs to understand the behavior of the access and the activities on the bucket, and that has informed our decisions to update and change the storage class of the bucket. So we see that already we're already meeting almost 4 pillars from the well-architected framework. I've talked about security, I've talked about performance efficiency, we've talked about operational excellence, we've talked about reliability. So that's already 4 pillars covered. And then if you go down again, you're going to see other things. I think we just have 2 more here. We have S3 bucket needs to have versioning enabled, which is also part of reliability. Reliability in the sense that when you enable versioning on the bucket and you have multiple versions of the file, when you delete one, the older version still exists, which acts as a fail-safe when data is deleted by mistake or by error. Okay, and then you can see also one that says here that ensure all data stored in bucket is securely encrypted at rest. Back to security. So from all this information that has been processed and this is being shared with us by Chekhov, after Chekhov has run a test on our Terraform code, we can actually summarize and say that yes, Chekhov and Terraform working together with the CI tool helps to ensure that we remain well architected in the AWS environment, because Chekhov is able to look at our Terraform code and say, hey, the way you wrote this Terraform code is not up to proper standard. You need to look at this, you need to check this, you need to check that. And please, Chekhov, this is just the basic Chekhov. Chekhov has more tools, and you can actually configure custom rules. So if you're an organization where there are rules around how people should access cloud resources, who should have access to what, which are not covered in the Chekhov dictionary, because this is more like a Chekhov dictionary of the basic standards, you can actually customize it using YAML or Python and integrate it within the Chekhov CI. So this is basically how you can remain continuously well architected using Chekhov and Terraform. Thank you very much.
Thank you so much, Uwiri. Really interesting talk. Really makes you think about how you actually structure your Terraform code, how you go about creating your cloud resources to ensure that it's actually fulfilling best practices that are as documented by the cloud provider. And also a big shout out to you for being the first AWS community hero in Africa. I didn't know that. So that was a nice, cool, fun fact. So let's just quickly have a look at social media. I want to shout out, I hope I'm not saying your name incorrectly, so please correct me in the chat, but Wachukwu, who put out a tweet about learning about the solution Atlantis that brings to make the developer workflows seamless with infrastructure as code. That's in reference to an earlier talk that we had. So I want to just thank you for interacting with people in the chat and also on Twitter, which is awesome. We've also been playing a little unofficial game here, Spot the HashiCorp swag. You've probably seen the water bottle. During that talk, my wife has kindly made me a hot chocolate. So this is the other swag that I'm showing off here. So it's a hot chocolate. Guess the brand. If you have any guesses, maybe drop me a tweet. My Twitter handle should be on the screen. But anyway, let's move on to our next speaker, who is another returning speaker. I thoroughly enjoyed this speaker's talk last year, so I'm really excited to hear this one this year. And it's my pleasure to introduce to you Sal Kimmich, who's going to give us a talk about culture clash, why DevOps, SRE, and cybersecurity teams have different motivations. And, as a former consultant, this is one of the friction areas I used to come across when I used to engage with my clients. I'm really interested to hear Sal's take on these things and try and understand some of the ulterior motivations. So over to you, Sal.
All right, welcome to Culture Clash on PagerDuty between DevOps, Site Reliability Engineering, and Cybersecurity. I'm Sal Kimmick, and I have worked either in some of these teams or very closely with all of these teams. And I'm going to talk about some ways that we can work on metrics that work for everyone in the new way that we have to do development. So here's what we're going to learn today. We're going to learn the what of site reliability engineering and the lessons we can learn about monitoring and observability from that space. Then we're going to talk about the why of how information silos happen in code and in time, where new vulnerabilities are coming into your source code from open source, and how mean time to update might be one of these new metrics that we want to consider if we want to have really good observability. So what do I mean when I'm talking about these things? I want to be really strict and clear here that when I'm talking about monitoring, I'm just talking about metrics. I'm just talking about data that I can get either directly representing or a proxy of a given machine. But when I'm talking about observability, it's a little bit of a different thing. So observability is looking at the state of a system by the proxy of a cluster of different things that we're monitoring. So this is a really good expression for it. So it's the property of a system using various forms of instrumentation. But I also want to make clear here that if you're doing observability well, what you're going to experience is looking at a system that is always decaying. This is just software that is built on top of hardware that is sitting on servers. Now, those are also being injected with cybersecurity attacks these days. There's a lot that can go wrong. So we're always monitoring systems that are, even in the most stable sense, going to decay. And signal processing is just that. It's looking at the state of a system that will continuously change over time. So we're going to look at a couple of statistics, and all of these are based around understanding our error budgets and how we construct them. So this is simply the amount of time that an error can accumulate for a given service over a specified period of time before the end user experiences any trouble. So I really want to make this clear. When we're talking about the spirit of SRE, we're trying to create a blameless culture where we have things that are allowed to go wrong because we have systems that fail due to the nature of thermodynamic laws. But the culture differs a little bit when we're then talking about cybersecurity, because I'm going to show you a list of a couple of the events that have happened, not even all of them for just this year. We just got done with the first quarter. And sometimes you can have a little bit of lax and error budget, but if you're looking at a cybersecurity 0 days, the first day that it's made public that something is a critical concern, then you really want to take the time to get that out of the way. And that's going to be your time to remediation. But good statistics and signal processing really just look like this. They're the effects of interest over the effects of variance. You want the effect of interest, what you're using to measure as the interesting proxy of behavior, to be as big as possible. You want the variance, the way that that system behaves in other ways, to be as small as possible. So measuring the components of a service. This is where we can borrow from the SRE to put statistics away in a really interesting way to lace the business value with the actual way that the architecture is behaving. So we're going to have SLIs, SLOs, and SLAs, service level indicators, objectives, and agreements. So this is just saying, and we're going to go over this just numerically, and then we're going to go over a time-based example to make this clear. So you have SLIs saying that something should be true. So a service should be available. Then you tie this to a percentage of time. So a service should be available for some percentage of a month. And then a service level agreement is really the if or else statement, which is if there's any legal consequence to a service having a downtime. So if we want to put this into the context of real time, then we want to look at that very common 99.95% availability for a component of a system. That's going to work out to 22 minutes or so of downtime for a given month. So you can really well observe and calculate very simply on a scratch pad the error budgets, how you want to construct them out of your SLOs. But we don't have that kind of same practice in cybersecurity, and we're really just maturing into that. So let's keep this as a framework in mind. One thing that we really do understand now is that in order to switch from just monitoring to observability, you really have to observe and, sorry, not observe, but evolve what it is that you're measuring over time. So change up what it is that you're measuring, measure 3 or 4 things, and then go into 1 or 2 that really make sense. But using composite SLOs, often availability and latency, if we're talking about reliability, is what you want to use. So I'm going to talk about another composite SLO that I think is really important for cybersecurity, because one of those aspects.
Houston, we have a problem.
This is how long it takes you from an incident or event, whether or not that is cybersecurity or something. 100%. Stably functioning system again.
Vote on it.
Some of the other aspects of this slide I have discussed about before. They're not so essential.
I really do
though.
think
Let's see
that
what we
we
need
are
to
just
discuss here
at
around
the beginning
SLOs,
of
SLIs,
seeing
KPIs. I
DAOs
know it's a bunch of
really
acronyms,
explode.
but I think
It's
they all make
already
sense in this
happening,
context.
and
I really
think,
am just
the
talking about ways that we can tie our business
the
logic
popularity of
to the
crypto
way
mining
that we
is
do
definitely,
our
and that whole
cybersecurity.
space
And in
is
this case, there's
definitely pushing
KPIs
that,
that you
but
can
I
keep
think
in mind, and
people
you
are
can
just
monitor
now
them
starting to
themselves if you
understand
don't want to use
that
any of
this
the open
is
source
it's a
tooling
social
that's
medium.
available
It's a
on this
new
slide.
substrate for us to be able to sublimate the
Now, when I
highest
discuss
value
the open source
information in
supply
a group.
chain, I'm talking about these 4 aspects.
And
You're going to be
with
familiar
that,
with at least a part of
we've
this,
got a
if not
new
all of this, if you've
superpower
been a
as
developer
human
for a
beings
while.
trying to work
So
together.
the open source components or
as we're looking
packages.
Hey folks, so sorry about that. We're having a few technical difficulties there with Sal's talk. We are working tirelessly in the background to try and bring that to you. So that we don't keep you waiting whilst we troubleshoot that, what we'll do is we're going to run a talk from one of our HashiCorp ambassadors, which has previously aired, about Nomad for students. This is just a short video, so we'll just run that in the background whilst we troubleshoot and see if we can get Sal back online. So sit back and enjoy.
Hello, everybody. Today, I'm going to be giving a lightning talk on Nomad for students. And so a little bit about myself. My name is Forrest. I'm a student in Ottawa at Carleton University. I'm a Rustation, so I like writing Rust code, and I really like Nomad. And so a little bit about the context of this talk. I've been using Nomad at Carleton for several months now to deploy a few applications, and I want to take a look through what this process looks like, but more from the student's perspective. And so a few tech specs of what we have. We have 3 server VMs going. We have 3 client VMs that are strong enough, lots of like a 32 vCPU, 64 gigs of RAM. So not a massive deployment, but we can deploy quite a few projects on it. We have 1 ingress IP, and we have definitely less than 100% uptime. That's not the end of the world for us. When I look through Nomad documentation and it says, this is not recommended for production environments, I'm like, but we're not a production environment. And so from the student's perspective, students have projects a lot of the time, right? Like if they're doing something for a resume, or if they just want to try something that's pretty cool, oftentimes they'll be doing some type of web project or something that will need some type of back-end deployment or front-end deployment or whatever. And so this is sort of what the objective of our Nomad cluster is being able to give students the ability to do this. But from a student's perspective who's just come in and just done their first Ruby on Rails tutorial or React tutorial, and they want to get something deployed, they're going to hear quite a lot of things once they get started in the deployment world. And so one of the obviously like the biggest things they're going to hear is like, what's this cloud thing, right? And so like the cloud can sort of be generalized as just a lot of computers that are somewhere else, and you can connect to them and you can run stuff on them. But that's really what they are. And then, I mean, the next step that you would take once you go down this rabbit hole a little bit is like this idea of cloud native. What's cloud native? Well, it's sort of like a lot of services that are running together, but the cloud native is also like a lot of levels of abstraction on top of that, right? Like we want to be able to reason about a lot of these services. How are they being run? How are they being started? How are they connecting to one another? And so there's a massive world of things under the umbrella of cloud native, but it's really about like the art of running services like at bulk. And so, of course, like the next thing that students are going to hear about when they go down this path of looking to deploy and finding the sort of like largest way, like the most popular way to do this, they're going to hear about Kubernetes. Hopefully they hear about Docker first, but let's say that like they're going to hear about Kubernetes somewhere. And so the thing for myself is when I got started learning about a lot of this world of cloud native and this world of deployment, it seemed to me like Kubernetes is really the only option that I had like to be able to use. And so I think that for myself, I really started by going out and looking in the Kubernetes community and seeing that there's like a lot to not just do with like production usage, but home lab usage and side projects and a lot in the world of Kubernetes. And so this is like a really great thing to see. There's like a massive community, so many people using it. It's used at these big companies. But then as soon as you start going down the rabbit hole of trying to learn it yourself, there's a lot you have to do. There's a lot of configuration to set up your first cluster. There's a lot of terms that you have to understand, even for like the most basic deployments. And if you want to have any production environment at all, there's a long list of steps that you have to go through, from installing Kubernetes on your machine or on your cluster, to being able to provision certificates, to having different like control planes and all of this stuff. And from the outside, you can go and watch a lot of tutorials, but there's a lot to do. And so this is what brought me to Nomad, is that I was looking for other alternatives out there, and I wanted to find the term for that thing. Like I just want something to run my my services. I have my Docker containers. I really like using Docker Compose on my one computer, but when I want to deploy, I need what is it that I need to be able to run these services? And so the word I was looking for was orchestrator, and there's really not a ton of options out there for orchestrators. But in looking around, I found Nomad. And this was sort of my entry into the HashiCorp world, where I then found a lot of the other products that are available as well. And so essentially, like for me, the biggest things I found really nice about it was that it was just like a refreshing exit of like this, like all of this terminology that I didn't want to know right off the bat. It gave me a single binary that I was able to start running some applications with in some simple dev mode, and a single purpose. And so I don't necessarily have to consider all of the things that I have to do to get this one thing running. Instead, I can just say, okay, well, I'm going to start by running one service, and it ran. I'm like, oh, okay, that's pretty cool. And let's try a little bit more and a little bit more. And then, of course, that leads you down the path of a lot of different tools that can work together. But the very core principle of orchestration is what it focuses on. And so at Carleton, we run several projects out of our Nomad cluster. And so these stem from projects that students have started with the like something that a student has made for students to use, but we also have a few other services running here and there to help either with some introspection into the cluster or some just backend stuff or anything like that. And so we also keep all of our code open source. And so the idea behind this is we want students to be able to come and learn how stuff is done, and then be able to sort of enter this world of becoming their own SRE. Like people can go and set this up themselves. So just a quick overview of the sites that we have that are running. So this one right here, discretemath.ca, was created by students who wanted to help create practice problems for the second year discrete math course. And so this is one that a lot of students struggle with. And so this site just has previous midterms that the professors have posted, all aggregated together. And you can go in and do questions. And so students saw this problem, students created an application to solve this problem, and then needed some way to host it. So we have university infrastructure, and this is sort of where I bridge the gap. Is that like I mean, if we take a look at like what's being run here, we have the back and the front end in Postgres, and you can run that on a virtual machine just by itself. But then as you start scaling and as you start adding more potentially microservices, or you want to build a second project or something, then there's a lot of technical burden that can come up down the road. So the second project we have is called Merged, and this is a way to show off projects that, or events that are being run at the university by the different technical clubs. And so I can see the events, I can see when they are, and I can see, if I click on it, it will bring me to the website that is relevant to. So I just want to take a look here quickly at some of the code that comes along with this, or rather is used to deploy this. And kind of just, I mean, if you know Nomad, this is really nothing special. We're using traffic as our ingress, or our reverse proxy rather. We're using connect to connect the backend in the database. But what I want to bring attention to is, for a student who doesn't know very much at all about the deployment world, if they were to take this template that is used for Merged and then just duplicate it and start working on swapping out the Docker image that's used and the host name that traffic is looking for, then there's really not that much overhead to getting something running on the cluster. Of course, there are a few things that would be a little bit different, like this idea of like a service mesh and connecting ports that are running across different clients. There's a little bit of stuff there, but in comparison to the tidal wave of information that I had to try and set up to configure some Kubernetes services, this definitely feels a lot easier to me and a lot more approachable, especially from students who are just entering this world and trying to teach themselves. All right, and so with this setup that we have, so we're running a Nomad at the university right now. This is giving us the ability to run projects that students are creating. And the question that comes up is like, well, can any student use this? If any student makes their own project, are they able to make use of this technology themselves? And we definitely hope that the answer is yes. And we want really for this project to be able to help improve the cloud native literacy for students. So when students are coming into a lot of these ideas, how are they approaching it, and what are they able to do to learn it? And so in the future, we're hoping that we can really expand this out as an ecosystem to be able to teach students through workshops, get more students helping to operate their cluster in a safe way, but then also offering this as a service to other clubs and societies who have their websites that are being hosted in different places, and being able to just keep it within Carleton. And so that's it for my lightning talk. You can reach out to me on GitHub, Twitter. I also run a separate from HashiCorp community Discord, where I try to encourage people to come and talk about projects that they're working on and help learn together. Please do reach out to me on anywhere you'd like to ask more questions. And I do hope that I can come back for a longer form talk sometime in the future with some cool stuff. Thank you very much.
Brilliant. So the bad news is we haven't been able to get Sal back. So that's very disappointing. But we'll try and work with Sal to try and get the content out there for you all to see. But the good news is we have another fantastic speaker lined up. We have Adifemi joining us, who's going to give us an introduction to Google Cloud Platform with Terraform. So really looking forward to this, and I'm going to hand it over to you. Take it away.
Hi, everyone. My name is Adefemi Michael. I'm a DevOps engineer at CCHub in Nigeria. And you can catch me on Twitter with the username ThatInfaGuy, where most times I tweet about anything that has to do with infrastructure, NFT, and also anything that has to do with Kubernetes as well, which I've been finding interest in as of late. For today, I'll be speaking on introduction to GCP with Terraform, which I termed as a quick crash course. So basically, we'll be looking at what GCP is offering, which is the benefits of using cloud in your environment, benefits of cloud provider, what Terraform is, how Terraform fits into the DevOps culture, and also we'll be doing a quick demo, spinning off something with Terraform on GCP, of course. So what is GCP? So GCP is a Google Cloud provider. That's the full meaning of GCP. So basically, it allows you to deploy stuff on on their end. So we all know that the old way of doing stuff is we have some servers on premise, and then we deploy whatever we want to deploy. We kind of like manage the servers ourselves on premise. We do the management, we do the upgrade, we do the updates of all those servers on premise. Now with GCP, which is a cloud provider, what they are offering is bring your code to us. I will help you manage the infrastructure. We help you manage where your servers, where your code will be running on. We help you do the updates. You don't have to worry about space. You don't have to worry about how much space you'll be consuming. You don't have to worry about how much RAM you'll be consuming. All you just have to do is bring your code. We give you the bare metal, you run your code on. And they also offer more than just giving you an infrastructure, more than just giving you a bare metal. They also offer something called infrastructure as a service, which is IaaS, which was the one I just explained. They offer what we call platform as a service. They also offer something called software as a service. So we must have interacted with Gmail. We must have interacted with G Suite. Those are some of their products that has to do with software as a service. So yeah, I listed some resources that you can actually find in GCP. As you can see, I listed the compute, which is more or less like which is a virtual machine, literally a virtual machine. We have storage and database, which comprises of a lot of database, both SQL and non-SQL database. We have networking. Of course, your compute might be needing to speak with your database, probably in a private VPC or in a public VPC, depending on how you actually want to structure, in a private subnet or in a public subnet, depending on how you want to structure your the way your compute interacts with your database, or the way your resources interact with each other. Also, they offer big data. They are very, very heavy on big data. They offer developer tools, identity and security for managing, for securing your resources on the cloud. They offer Internet of Things. They offer cloud AI management tools and data transfer. These are like, I just picked a few points from what GCP offers. They offer quite a lot of resources. Moving on. So yeah, benefits of using cloud provider offerings. So there's scalability. Of course, you'll be able to both scaling, horizontal scaling, and also do vertical scaling as well. There is availability. These resources, the resources you are deploying on GCP is not just in a particular location. You can do a multi-region deployment. You can do a multi-easy deployment, which is availability zone deployment. You can also do a multi-region deployment. Basically, you are deploying in more than one region. That makes that particular, what you are trying to deploy, that makes it available. And there's also elasticity as well. So IAC, infrastructure as code. Infrastructure as code, just say you have these resources that you want to deploy, but you don't want to go via the console. When I mean the console, I will show you that once I'm doing my demo. So you don't want to go via the console to deploy these resources because of time. You want to manage time. You want to be consistent with what you're doing. IAC helps you do that, which is infrastructure as code. Basically, it means you are deploying most of your resources to that particular infrastructure by writing code. You don't have to go through any sort of press and play on the console to get your infrastructure deployed. And I said, what are some of the IAC best practices? These are more or less like the advantages of using IAC. We have speed, of course, because you are writing your infrastructure, you are deploying your resources to your infrastructure via code. Definitely, there is high tendency of speed, and sometimes your code might be reusable. So you don't have to recreate the wheel. All you just have to do is plug, copy from what you've written before, paste, make some changes, and then deploy. There's also consistency, because what you are deploying to your cloud resources will be consistent, in the sense that if you deploy something today and you're trying to deploy it maybe in a week's time or 2 weeks' time, definitely there will be consistency in what you are deploying. And there's also diverse integrations. These diverse integrations means you can easily plug a particular IAC tool to deploy to, you can use an IAC tool to deploy to both GCP. You can use that same tool to deploy to AWS. You can use it to deploy to Oracle or even Terraform Cloud as well. So that's what diverse integrations that is referring to here. Yeah. So one of the most popular IAC tool we have out there is Terraform. Of course, I'm a fan. I'm a big fan of Terraform. I've actually been using Terraform for the past 3 years now, both using it for my own personal projects and also using it for external projects as well. And in my company as well, we are very, very heavy on Terraform. I listed some of the companies that actually use GCP in Nigeria. Some of the companies that use, we have a lot of companies that use GCP in Nigeria. We have CCO, we have TeamApt, also Terraform as well. Some of the companies that use Terraform in Nigeria, CCO, which is the company I work for, TeamApt uses Terraform. We have some top companies as well, which I think Nautilus Technologies as well uses Terraform. So the tool is not just new in Africa, it's not just new in Nigeria, it's a tool that people are getting conversant with, people are knowing that, okay, this tool is actually used for deploying infrastructure, for creating infrastructure, and it's fast and easy to know. If you have a basic understanding of programming language, of course, you can easily pick up this tool and use it. The sweetest part about this tool is the for loop, and also using the ternary operations. It's a very, very easy tool to use. So yeah, I placed the diagram here that shows the DevOps circle. So basically, these are some DevOps jargons that you'll be seeing out there. Of course, almost all these tools, it's not necessary for you to know them. But if you look at the top right, you will see Terraform in there as well. So definitely for deployment, in the CI/CD pipeline, there is a place for Terraform. So basically for deploying to infrastructures, of course, you use Terraform. For managing your infrastructure as well, you use Terraform. Yeah, there's Ansible, but Terraform does this management for you very, 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 very well and quite easy. So yeah, let's do some demo. So yeah, for the demo, I've written some code prior before now. Basically, what I'm trying to do is I'm creating a resource, a Google Compute instance. I'm using variable to actually pass in my name, variable in the sense that I'm not giving it a generic name. The name will be passed in variables.tf. Also the host name as well. I'm grabbing my current project configuration from this data resource that I created. So with data resource, you can actually use it to grab, if you have an already created resource, you can use data resource to grab that already created resource, which is what I'm trying to do here. I'm using variable to also declare the zone in which I want that instance to be deployed in. That's the virtual machine to be deployed in, and also the type of virtual machine I'm using. This place, I'm passing metadata. Basically, I'm trying to, you can see change me here. Of course, I'll be pushing this code to GitHub if anyone wants to clone it and probably try it on their end. At this point, I'm creating a public key called ID IS8_AZ, which is going to be stored in my own path, in my home directory. Also, yeah, I'm calling in a startup script. Startup script in the sense that I want a script to be run once I start up my instance. This place is the networking part that I told you about. I told you with deploying things to any cloud provider, you have to also take care of your networking. Maybe you want it to be open to the public, or you want it to be private. So at this part, I'm doing all those stuff, doing the networking here, creating my subnet, the subnet for the project, which, as you can see, I'm grabbing it from the data resource I created here, and also the network IP. Yeah, I'm trying to make sure that this resource I'm creating, which is my Google Compute instance, this VM I'm creating, won't start unless all this particular data resource has grabbed whatever needs to be grabbed. So which is why I'm putting a depend on variable here. So when you see a depend on variable, that means this particular application is depending on this particular resource, is depending on another particular resource. And at this point, I put in a boot disk. Of course, if you're deploying stuff to GCP, you'll be familiar with almost all these terms that I'm using. Of course, you have to add a boot disk. And with this boot disk, I'm actually using Debian Cloud, Debian 9. You'll see it in my variables.tf. Also, I'm owning an on-host maintenance, and I'm doing automatic restarts to be true. Of course, your resources you need to be deployed in a particular service account. So I'm putting in the scope here, and I'm tagging my resource, giving it web server name, just so say for instance, I want to manage my resource. I can know that by these tags, I can find this particular resource. I'm creating a compute address. That's an internal reserved subnet IP, which is I'm reserving a static internal IP address for my compute, giving it the region in which it will be deployed to, the address type, which is internal, and also connecting it to Google to this particular resource called Terrasub. And if you look down, if I scroll down, you'll see the resource being created here. So this one is actually optional. So if you are creating your own service account yourself, of course, you can also do that. But not forgetting you need to create some IAM admin role and assign it to this place. But this can be removed, or if you want to go ahead and create that for yourself, you can do that as well. At this place, I'm creating the compute network. I'm creating the VPC. At this place, I'm creating the subnet. Of course, if you look up here, you will see I'm attaching the subnetwork to my compute address. So it is at this place I'm creating the subnetwork, giving it a CIDR range, the region in which it will be deployed to, connecting it to the VPC in which I created up here. And I said this is a custom subnet. Of course, it can be changed. The aggregation interval, which this is the log config, the flowing sample, and also the metadata as well. And as you can see here, I'm giving it some secondary IP range, the range name. This name can be changed, and also this CIDR range can be changed as well to anything of your choosing. And at this place, I'm creating the firewall. Of course, I want to open some ports because I'm deploying a particular application to this to my instance. So I want to have some ports open, like 80 to allow me reach out to HTTP, 22 to allow me SSH into my instance, 443 to allow me for HTTPS, and 3389. This is just a random port actually for the application I'm deploying. And then I'm making sure it is open to the public, and I'm giving it a tag as well, which is web server, because it's the tag I've been using from above. This one are actually output. Basically, I want to see the project of what I created up here, which is for this data resource, which is what I'm doing down there. Let's go to provider output. So with output here, you can get your VPC name, you can get your subnet name, you can get your subnet ID. These are easy when you visit Google. Let's do Terraform, Google computes. So the Terraform documentation is quite easy and very, very good to understand. So if you check attribute reference, these are some of the attributes you can get out: instance ID, the metadata, the self link, the tags, the label print, the CPU platform. And also if you check argument reference, these are some of the arguments you can pass in. And they have some very, very easy to use plug and play example usage that you can easily plug to your account. As you can see, they are creating a service account here. And as you can see, they are creating the compute instance, just like what I'm doing, the zone, the machine type, and so on. Yep. So let's go to provider.tf. Of course, before you deploy a particular resource, Terraform needs to know the provider that is actually using that resource. It's easy for us to say, okay, this is the provider I want, but of course you want to specify the project. Of course, if you are familiar with GCP, you will know that with GCP works with anything that GCP works with projects. So you have to actually deploy your resource or your application to a particular project. So which is why I'm specifying the project here in my provider. I'm specifying the region in which I want my resource deployed into, and also the zone. If you look at my variables.tf, this is where I'm passing in all the values. Of course, you can see the project. I'm passing in this project name, which I grabbed from here, the project ID, sorry, which I grabbed from here, and then I'm passing in the region, the zone, the name I want to give to my VPC, the CIDR range, and if you look down here, you'll see where I'm passing in the private IP, the script that I want to install. I'll show you the script very soon. You will see where I'm passing in the disk size, the VM type, and I'm also passing the OS. I'm using Ubuntu. This can be updated. I'm using Ubuntu 2004, of course, it can be updated to the latest version. Yeah, so for the user data, if you look here, this is what I want to be. You know, in my main.tf, I mentioned on the script as a startup script, yeah, in my main.tf, and I call it variable.userdata. And if you look at my user data variable here, you see my user data variable is actually referencing a file in a folder. And this is the file, the shell bash file is referencing in this folder. So basically, is a shell script that does that echo script started into this script log. Use a variable code file to pass in this particular stuff. Basically, what I'm doing here is just a simple HTML file, such that when I run Terraform Apply or Terraform Plan, Terraform Apply, you see this displayed, and then I'm also passing in a YouTube video, of course, a very funny YouTube video. And then at this point, I'm installing Nginx because I'll be using Nginx as my web server. I'm allowing Nginx HTTP. I'm enabling Nginx, displaying the status of Nginx. And at this place, basically, I'm just copying this file, which I created here, as you can see. I'm copying it into this particular part because Nginx will be reading from that part. So I'm copying it from this particular part. And yeah, that's that for our application. So Terraform has some inbuilt command. If you look at my screen here, I did the Terraform format. Basically, if I do this, say for instance, I do this, I'm trying to create a wrong format right now. And then I save this file. If I run Terraform FMT to format my file, it's actually going to format it as you can see, it has formatted the file. And also there's also something called Terraform to the first step you do when you want to apply your configurations to Terraform is to initialize that particular Terraform configuration by running Terraform init. So Terraform init will look at your provider file, know that okay, this is a Google project. As you can see, it's going to grab the latest version of HashiCorp Google, grab that, tell you, oh, this has been successfully initialized. And one thing I do that you might, as a Terraform user, is I use Terraform Validate a lot to check if my configurations are correct. So when I run Terraform Validate, I can check if my configurations are correct. If it's correct, it's going to tell me success. But basically, this is not checking your code. This is not checking your what you are deploying to the website to GCP. No, what it's just checking is it's checking your code format to see, okay, I'm expecting a string here. Am I seeing a string? I'm expecting a number here. Am I seeing a number? So let me give you a quick example. So say this, I put 2 here. Instead of Terraform VM, I put 2. And let's save this. Let me run Terraform Validate again. Okay, let me put a type here. Type is string, yeah. But I put 2. Let me run Terraform Validate now. Scratch that. Let's see, default is, oh, let's say I put Boolean here, let's see. Sorry, default is true. Let's see, I put this. I'm trying to create an issue. Yeah, exactly. So as you can see, Terraform Validate is telling me the default value is not compatible with the variable type. So the variable type it is expecting is what? Is a string, but I'm putting in a list, which is not compatible, which is why Terraform Validate is very good. So like I said, it's just checking your variables to the type of variable you are using and the value you are passing to your variable. That's just what it's checking. It's not like it's checking the code that you are deploying. It's not like it's checking what you are deploying to GCP, to the cloud provider. Let me do a Ctrl+C and go back to where I was coming from. Yep. So let me run a Terraform format and then the Terraform Validate. I've run Terraform init, so let me run Terraform Plan. Of course, I've passed in my default value here, as you can see, so I don't have to specify. Maybe I'm using a TFVAS file, but this is, you can use TFVAS file to actually pass in your values, and you can pass in it via default. I'll show you that if there's time. So yeah, as you can see, these are what will be created when you want Terraform apply. So it's telling you Terraform will perform the following actions. We create a compute address. This is the address type, the creation timestamp. We have the firewall as well will be created. As you can see, this is the priority. This is the network. This is the project in which the address will be created into, the source range, and the ports that will be allowed, the type of the protocol, which is TCP. It's going to be creating the compute instance, as you can see, E2 micro, This is the metadata the script is going to be passing in. Of course, this is the, as you can see, the key is saved here locally on my system. This is the script that will be passed in. Yeah, and this is the zone in which you be deploying to. Basically, Terraform Plan just show you what you are going to deploy before you run Terraform apply. Yeah. So let's do a Terraform apply and see our configuration work. Terraform apply. So it's going to ask me, of course, Terraform Plan create a Terraform state for you. Definitely, you won't see anything here until I run Terraform apply. Create a Terraform state log file for you. Basically, this is just for state locking. And then it creates this Terraform folder for you. This one downloads the provider that you are using, actually, this .terraform part. So put in a yes here because I want to accept these configurations. So yeah, we will watch our compute get created now. Creating network, project, disable, enable it. Oh, so I have to enable this and then make a retry. Okay, let's do that. Let's enable this and then make a retry for that project. Yep. I'll wait for this to load. Enable. I'm actually meant to enable Compute Engine API. So enable shouldn't be. Let's see. Enable billing. Okay, let's activate this. So enable. Let's see what's going on. Enable billing, Compute Engine API. It should be enabled by now. Let's see what's going on. Okay, should probably create. And without enabling that, we actually can't push. We can't run these configurations. So yeah. So sorry about that. I have to put in my card details to make sure I have all this set. And as you can see, my Compute Engine right now is enabled. So let me run the Terraform apply again. So yeah, it's good that I'm facing errors. You can all see that in action. Let me see if I have any errors I have to deal with. It's done. Activated that. Okay. Yep. So it's creating it. As you can see, it's creating the network, creating the firewall hand in hand, creating it in this particular project. As you can see, the VPC has been created, and we can confirm that. Can confirm that. Yeah, let's check network. Let's see. Let's look down. Yep, there's it. As you can see, Terra VPC, and as you can see, created the subnet. You can see the CIDR ranges here as well. So yeah, like I said, I told you after running Terraform apply, as you can see, it says 5 added, 0 changed, 0 destroyed, and it did what? It gave us this the subnet CIDR, the name of the subnet, SSH to this particular place. This is the IP of my instance. The port that is being opened, the protocol. These are actually the outputs, and you can easily visit here to see what we deployed. So let's visit this link. Make a reload. Let's see what's going on. Go to my instance, compute engine. Oh, I'll need to register that domain. I see, that's what's going on. That domain is not registered. So that will actually pose some issues. But let's see. Let me grab this IP. Let me use this IP, the public IP. And I think this should work out just fine. Yeah. I'll need to change this. So yeah, let's just do that. Let's do that right now. Let me make these changes and say welcome to HashiTalk Africa, and then save the file. This will talk about the consistency I was referring to when it comes to deploying to Terraform resource. And as I just added a little snippet of HashiTalk Africa for last year. So let me make these changes in my install.sh. As you can see, this is meant to be in welcome to the first. So this should be welcome to HashiTalk Africa. Let me just grab this here. Control C. Welcome to HashiTalk Africa. Control save. Let's do a Terraform apply and let's see if we have any changes there. Terraform apply. While we are waiting for that to apply, yep, you can play the video and all this stuff. Yeah, that's some of the things you can do. Okay, yeah, it's applying the configuration. It's saying you want to change. Let's type in a yes. So this will actually allow us to install this. So let me pause the video and come back once it's done. So this is done. So let's see our latest changes. Let me grab the IP. Okay. 253.11. Let's see our latest changes. So that didn't work. So what we could do is we could do a Terraform destroy. So I'll just be passing in the flag to make it fast. And then we'll do a Terraform apply. So this way, you're actually destroying all the resources that you have created. And then we'll do a Terraform apply. Then let's come back when this is done. Okay. So yeah, the resources have been destroyed. And now let's do an apply, a Terraform apply. I'll just be using the auto approve command as well to apply these resources. Yeah, so I'll be putting in, that's so it's going to be applying by itself automatically. And let's see what happens here. Let's come back once this is done, okay? So yeah. So we have so we have all resources created now. So let me just grab the public IP and see if we have any changes. Let's see if we have any changes here. Yep, and there we have it. So we have our changes. Welcome to HashiTalk Africa. HashiTalk, this is a YouTube video, and nothing more. So yeah, that's a simple demo. I'll be pushing this code to GitHub, sharing the link. You can have access to it. Don't forget to attend some of our meetups. We have Lagos HashiCorp group that you can attend, that you can join. Also, I think the organizers will be sharing some of the meetup link with all the attendees. Yep. Thank you guys for coming, and thank you for listening. Bye.
Adefemi, thank you so much for that talk there. You know, if you've never seen GCP in action before, there's actually no better way to learn some of these cloud providers than using the Terraform providers. So just seeing that end-to-end working, it was really useful. I've myself have been using GCP for a short time, and I can tell you that just going through the Terraform provider and deploying resource using that is one of the ways that I learned how that cloud platform works. So thank you very, very much. Just before I continue, I just want to remind everyone that we will be sharing these talks in the coming weeks on our YouTube channel. So if you're not already, please do subscribe to the YouTube channel. And if you'd like, hit the bell so you get notifications when we upload new videos. But yeah, in the next few weeks, we should be uploading all of these talks here. If you are just joining us and you've missed some talks and you want to catch up, or if you've been with us all day and you'd like to rewatch a talk to extract the extra value out of it. So just all you have to do is subscribe to the YouTube channel and keep your eyes open. Right, so let's introduce our next speaker, who is a good buddy of mine. He used to hang out on my live streams. I used to do a lunchtime session called Vault Brown Bag, and this gentleman used to hang out in the live streams and help me out when the demo gods were really against me. So yeah, fantastic to be joined by Guy today, who's going to discuss the cloud operating model. Actually, I think I might actually be sitting in with this talk with Guy. So I'm looking forward to this. So I'm going to hand it over to you and excited to hear what you have to say.
Hey, Rob. Yeah, thank you. It's a great pleasure to be here. And you're a great streamer. It was great fun. Unfortunately, the time zone aligned as always. I will say I do have chat over here. I'm not sharing my screen. I am reading chat, so if anyone has a question, feel free to shout out. And yeah, Rob, I wanted you on to make this a little bit more conversational and get your views on it. Let me just share my screen so we can start.
I think we may have lost Guy for a split second. Let's see if the streaming gods come back and show mercy on us.
Am I back?
Guy, you are back with us.
Okay, share screen, share.
Okay, I really do think the streaming gods are having way too many opinions today. Hopefully we can get Guy back. But for anyone that isn't aware of the cloud operating model, HashiCorp has published various blogs and papers on this matter and some of the things that go into it. I don't want to say too much on it because I don't want to take anything away from Guy's talk. But if you are looking for extra reading material, if you just kind of Google HashiCorp and cloud operating model, you will see these things. Also, just to quickly plug, one of the other things I do is I run a podcast, a cloud security podcast called Keeping It Secure. I'll actually post a link to that in the chat in just a moment. It's available on all platforms, so SoundCloud, Spotify, Apple Music, wherever you listen to your podcast, you can hear Keeping It Secure. And that's one of the topics of conversation that we actually have on there is the cloud operating model. We have a few episodes where that has definitely been a theme that we have discussed. So Keeping It Secure, it's myself and my co-host DevOps Adil, and we'll post that in the chat. But I think we may have Guy back, so welcome back, buddy.
Hey, and hopefully now I'm using Firefox and this time it won't crash. Yeah, it's a pleasure to be here. I should be sharing my screen. There we go. Lovely. Yeah, pardon that. Everything works against us. Yeah. No, so the cloud operating model showcase. Sorry. Hi, everyone. My name is Guy Barros. I am a solution engineer here at the UK and I region. Thank you for being in this session. It is a pleasure to be here. And we are going to talk about the cloud operating model. More than talk, we're going to show it, right? Because the first question, and like Rob was saying, it's like, what is it? Well, if we hop on to the HashiCorp website, right? Where we can actually see everything that HashiCorp does, and we see all of the solutions. There's Packer, Terraform, Vagrant, Waypoint, Nomad. A lot of this that we talked about, Vault, Boundary, and Console that we talked about today, right? There's also, if we come back over here, a series of different use cases that says like, here is different things that you can do with all of these solutions. But if you come into solutions and talk about cloud operating model, right? It's basically how to deal with complexity, right? I loved this screenshot, right, from the previous session, and which shows kind of everything that we need to think about. Right? And if we and this is just from a pipeline perspective, right? And we saw today, sessions from Anita, from Victory, from Ewere, that it's developer experience matters, and simplifying that developer experience is and making it easier to create value is what it's all about. Right? It is where we go from this. And the cloud operating model, it's like, okay, how do we think about these problems, right? How do we break it down? Is it on cloud? Is it on premise? Everything is dynamic nowadays. We just go back, right? And that was one of the greatest shifts from what we used to do 10 years ago to what we used to do today, right? Where everything was more static, more traditional. You had one data center, 15 servers or one server. And now you have the cloud, you have on-premise, you have different cloud providers, AWS, Azure, GCP. What do? We have to do everything, and you have to plan everything. Even CI/CD providers in the same organization, you have more than one. And kind of, just to get started, just to say, okay, there's a necessity for a code that I'm developing. I need to get started.
Where do you get started?
Exactly. So let's break this down, right? And let's try to facilitate this. And that's what the cloud operating model tries to point out. It's like, okay, let's take down this complexity. Let's think about 4 focus areas, and let's take it from there. So we have, the whole infrastructure provisioning bit, secrets management, communication, service connectivity is the nice word for it, right? And then kind of actually deploying our applications itself. And then we do have like a different blueprint of, all right, what, where do we start? Where do we mature? And kind of that is what the operating model starts from, right? Okay, perfect. Lots of words, lots of pretty pictures. What does this look like? Like, okay, we saw Nomad today, and we saw a lot of Terraform today. We talked a little bit about Vault. We will look at Console, but we saw Waypoint. How does it all tie together? Right? What does great look like? Luckily, another buddy of ours, Rob, from the US, gave a pretty picture to look into this. And this is it. I'm gonna go full screen here for a minute. I'm not gonna do, and it's not gonna be only slideshows. I will change it out for a minute. But I do want to talk about this.
And when you said Rob from the US, I'd love to take credit for this beautiful diagram, but he's not talking about this Rob. This is Rob from the UK and Ghana.
No, Rob, our colleague, Mike Fonseca from the US. Sorry. You're our Rob, man. You're not from the US. You're our. It's a Mia. Yeah. So, and kind of this is the full picture, right? You template your immutable infrastructure with things like Packer. You have your developer environment with Vagrant. You facilitate your CI/CD with Waypoint that we saw today. You abstract away the complexity of deploying with Nomad. You handle connectivity with Console and Vault. And kind of once you set into, these solutions into a developer experience, kind of this is what comes out in the end. Now, this is what I want to do. This is what I've done, right? It is an iterative process, right? And I am improving on the code, and I will share the repo out of this in a minute. And I am just, okay, come over here, and I've lost chat. Sorry, everyone. Okay, wait, right? So what is it that I've done? First of all, I used the power of Terraform to remove the complexity of setting up the developer experience. So basically, as a developer, I have a necessity. I need a new API, right? I have ADHD. I need a to-do list, right? And I'm gonna create an API to have my tasks that need to be done today, right? And I'm creating that from scratch, right? So instead of having to go to GitHub and set up my repositories and set up my CI/CD platform, instead of going to Docker and create the namespace that I'm going to deploy that solution to, and then I have to go to Terraform Cloud and create the workspaces that I'm going to do that on, and then kind of create the Nomad job spec to actually use for deployment, and the Packer, which is going to actually build the Docker image for me. I can use Terraform to facilitate this whole process. Now, I am doing all of, where's my mouse? All of this, wait. I am doing all of this on another project that I have, which I call the demo stack, but which is basically a shared dev environment. It's on AWS, but it could be on different clouds, right? But it's my development environment. I have Nomad, I have Console, and I have Vault. It's all working together. Where it's being hosted, it doesn't really matter because it is on AWS, but it could be on Azure, it could be on GCP, right? So let's just walk through with this. It's not a magic trick, it is purely technology. Here on my Docker Hub, I only have one my actual app that I was testing to make sure that everything worked a couple of days ago. I have on Terraform Cloud a personal organization that, let's just say, it's like a team organization for this specific app that has nothing on it yet. And then I actually have my team's organization on Terraform Cloud, which has a lot of things already done, right? And one of these things is that development environment, which is here. And we can see the outputs, and we can see that I ran it about an hour ago. And if we look at the history, we can see that it wasn't really working before that, right? So I had to do a little bit of live troubleshooting. And once we hop into these development environments, the only thing that I'm actually currently running, actually there is more than this, is for this demo is MongoDB. Right? I have MongoDB as a service, so I basically run it wherever. Right? And if I look at my services, I can see here as well, I have MongoDB. Right? And I saw that it was registered via Nomad, so I have that integration there already. Okay, cool. Now let's start. Time to develop my app. So I'm gonna come here, and this is all of the Terraform code that all of this magic does. And Rob, I may need you for a minute because, as we do, 5 minutes before hopping onto the session, I mucked about with the source code. So if this fails, I will need your help to kind of entertain while I debug. So let's go, just Terraform apply.
And I am the worst person to ask for that. You should see my code.
Yeah. So application name. What shall we name this? HashiTalks Africa. Are you okay with this name, Rob, or do you have something better?
Let's go with it. HashiTalks Africa.
All right, I'm gonna do a lot of things. So if we look here, I'm just gonna drag this up a little bit. Of everything that's gonna be done, we're gonna create 46 different resources. We're not gonna change anything because there's nothing there. We're not gonna destroy anything, right? Okay, instead of seeing the code, we're just gonna go ahead and press yes. There we go. It's creating, right? It's going off to Terraform Cloud. It's creating my workspaces. It's going off to GitHub, and it's creating my repositories. It's going up to Docker, and it's creating my namespace, right? It's going off to Vault and already configuring Vault with all of the integration from the above. Even in Vault, it's creating the integration with console as well. And it's going off to Terraform, creating the integration with GitHub. So all of that complexity, all of that manual work that I would need to do just to get started developing my application is getting done for me. Right? And secrets management as well. Like I didn't have to input a secret here, right? It's hard coded for now, but this should be coming from Vault, right? And using dynamic secrets, so it's only available from this session. And I am glad that the changes that I've done right before the sessions have worked. So we have all the apply complete, so 46 resources added, and
Give
we
yourself
have
a pat on the back as well.
And the wonderful of this, we have a lovely message. Your CI/CD pipeline configuration has finished. Happy coding. So let's code. This way, let's go back now to Docker Hub, and we're gonna just finish F5 over here, right? And we see now that we have a new namespace, HT Africa. There's nothing in it because we haven't pushed anything, but there it is, right? And now in my organization, we have all of the different workspaces that I will need if I need to set up a specific environment for this application, right? And we see that they're all planned. That means that they are already integrated with the repositories that were dynamically created as well, which are all of these. Now, for this specific use case that I'm showing here, I've abstracted the way and the necessity of cloud resources by my platform. So I'm just going to go ahead and focus on developing of my application. Right? So the first thing now that I have my repo is clone the repo. Clone, rank, right, and then cd Africa, code yoink, right? Now, as a good developer, which I'm not, but everything that I do, I copied from someone that has already done it before. In this case, I'm just copying it from myself, right? So while I, take a lot of time to actually develop my code, and it's already finished, let me just check that it's correct. So we do an npm install, right? And this is going to take a couple of minutes. So while this is happening, let's take a look at the two templates that I had. The first one is the Nomad job. Right? And what this is going to do is going to, when the time comes to deploy this application into my shared dev environment, it's going to abstract the complexity away from there. Right? What is important here is that my identifier for this is the application name itself, right? So I have a task called HT Africa, right? Which I'm going to use the image that I already know what the namespace and the Docker repo, the Docker Hub repo is going to be, because I created it, right? And because I know exactly what I want to do, in my Terraform, I already said, okay, this is going to connect to Mongo, so I already put in those environment variables there. Now, one of the things that is interesting here, and I will come back to it in a little bit, is this. Right. I'm setting the Mongo server that my solution is going to connect to as localhost. Does this mean?
Can you just bump up the text size a little bit for us, please?
Yeah, control.
Perfect. Thank you.
Right. So let's rank. Right. Cool. Now, so what I'm looking at here is that, I'm connecting to localhost. Am I actually connecting to localhost? No, because if we go back to console, right, and we look at MongoDB, it's actually running in one of my workers, right, in this IP address, in this worker. But one of the great things about the integration with console is that console is a service mesh, right? So that means that it handles connectivity for me, right? And this is where I define that connectivity. First of it, I give it an identifier, right, which is all coming from my Terraform code that I created. This is all for the networking perspective. We'll come back to it in a little bit, right? But this is where the magic is happening. Basically, what I'm saying is like, hey, console, I need to connect to MongoDB, right? And I want to use the local bind port 27017. Figure it out. And then console, what it's going to do, because it is a service mesh, is going to make that connectivity for me, right? So it is using the power of console service mesh envoy proxies to actually make this happen. And this is all done from Nomad. And all I need to do to actually get the Nomad running is just deploy it into Nomad. But before doing that, I actually need to build. HD African. So before I can deploy my application, I need to have it into Docker, right? And for that, I'm going to use Packer. Now, Packer is another one of HashiCorp solution that facilitates creating images, right? In this case, I am using it to create a Docker image. But the beauty of Packer is that it abstracts away the complexity of creating images, right? So in the same syntax that I'm using to create Docker, I could go ahead and create an AWS image, a VMware image, right? A Azure image, a GCP image, a Proxmox image, right? ISO. And it uses the same syntax. So it kind of facilitates that complexity, right? And so again, we're talking about removing complexity away from the developer so they can focus on developing. Right now, I ran the command to actually go off and build it and deploy to Docker manually, right? Packer build. Ideally, this should be done as part of my CI/CD process. And that will be done in version 04 of this process. No, what we don't do today, we always promise for tomorrow. And ideally, not only should this be done by a CI/CD pipeline, this actually should be done via waypoint. So then I don't even have to worry about it. Okay. And I have that visibility of the whole process going on. Okay. Now, when I did this yesterday, it took 3 minutes and 55 seconds to actually build the image and deploy it to Docker.
But now you're doing it live. You know the rules, man. You know the rules. If it takes 3 minutes, it's off air. On air, it's going to take 10. But no, this is awesome. And I think while we wait for that, I'll just point out. So when I started using Packer, it used to be I don't know what you call it. Do you call it a Packer manifest or a blueprint? Or I don't know what you actually call the actual Packer image. But when you defined that, it used to be that you had to write it in JSON. One of the advances that the very awesome Packer team has made in recent releases is now it supports HCL or HashiCorp Cloud Language. So it's one of those things where if you're used to writing Terraform, if you're used to writing Nomad jobs or your config files for Vault and console and so on and so forth, you have a single workflow, a single language. So it's not really a new skill. You just need to understand what the different components are, what the different standards are in that. And there's very good documentation for that. But yeah, I do like that. I do like the fact that I can just use HCL from start to finish throughout my entire workflow.
And speaking of HCL, and speaking of the wonderful Packer team, right? Well, another improvement that they've recently done as well is think about how do you integrate then, Packer with Terraform? And one of the answers with that is HCP Packer. Okay. Now, what is wonderful about this is that now you have a place, HCP Packer, to hold the metadata of all of those images that you are doing. Again, version 06 of the workflow that we're doing here will have this integration, right? And the idea is that it's like, okay, I went off, Packer built the images. It built it on Azure, it built it on AWS, it built it on GCP, and it built it on VMware. How do I find these? Well, I now can integrate this with Terraform, and Terraform can go off and say, okay, I want to get this image, right? Or in this image. And then you don't have to worry about kind of, is it the right version? Is it available in this region? Is it that? Where do I deploy it? Do I call it one thing on one region? Do I call it on the next one? What's the version? You remove that complexity away from your CI/CD process. You say, Packer, do it for me, and Terraform, go bother Packer with this stuff, and you facilitate a lot of it. The HCP platform itself, it is something quite new, but it is not quite new. It's 18 months as old, but we do have HCP console, we have HCP Vault, and more in the future, which I can't say more about at the moment. Hint, hint, wink, wink. Okay, so this is still building. Yeah.
I think HCP is the way forward, though, because I think when I was a consultant, but one of the things that I used to say to myself is I love the value of Vault, for example. I love the fact that as a developer, I can just interact with an API, I can access secrets, I can write secrets, I can encrypt and decrypt things, I can verify data, I can sign data, I can do all of these things. But what I don't want to do is manage the infrastructure for that. I don't want to have to patch the underlying operating system. I don't want to have to manage the Vault upgrades as new versions come out and so on and so forth. I just want to make sure I can build my applications and do it in a secure way. So for me, what HCP Vault has done is it's taken that operational responsibility for Vault away from even the operators, let alone the developers, right? And just allows us to extract the value from it. So I view Vault no longer as like an identity broker or a secrets management platform, but in my opinion, I see it as a standard library for security. You can do pretty much anything that you need to do in your application for security purposes, from accessing secrets to even implementing multi-factor authentication. We have that mechanism in there, and cryptography, which is one of the hardest challenges that developers face. So fantastic way of dealing with things is going towards HCP.
Yeah. No, and I love that it's a standard library, because you're right. And as a standard library, we should be using it when we set up different resources. So like, okay, when I set up my database in RDS, I should then use the Terraform code that I'm using to set up that RDS instance to also go off to Vault and says, here's a dynamic secret engine with a specific profile, right? So that way I get into the habit of using dynamic by default, right? So now because it's like using Vault is easier than anything else, including using static secrets, or using hard-coded secrets, because it's not hard coding and I hardly need to think about it, right? And it does facilitate the process so much, and kind of, again, you take away that complexity. We're always taking away complexity. And speaking of taking away complexity, we just finished our build in 5 minutes and 38 seconds.
Broke your world record there, didn't it?
Yeah. So if we just have 5 here again, we can see that now we have a latest in version 001. Okay.
I think you should pat yourself on the back again.
Right. Okay. So now that we've built our process, let's go ahead and deploy it. So I'm just gonna, again, this should be part of our CI/CD pipeline coming in here, and it will be part of the CI/CD pipeline soon. right? Let's just do a quick plan. See if I haven't forgotten anything. Nope. Okay, so now we go ahead. Nomad, run. Okay, cool. So now we see it. It's getting deployed. If we go back to our Nomad job spec, we can see that I have the count of 1. Actually, and I'm just going to change this to 3. All right, and I'm just going to leave it that one. So it's off, it's deploying. If we go into Nomad itself, right, we can see here it is. Right, HT Africa, it's there. It's getting started. It's downloading all of the Docker images. It has the limit CPU, or it has kind of the reserved CPUs that I have for this spec, and off it goes. If we go off into console, we can see it here as well. Cool. Now, and we actually can see that it configure and that it needs to talk to Mongo, and that is working. And what's next then? If I just go back to, so we're all the way over here connecting. Next then would be to configure our public facing network infrastructure, right? Firewalls, load balancers, and things like that. Now, there are different ways of doing this, and to facilitate it for this showcase, I'm using Fabio. Fabio is a software-based load balancer that one of the backends that it can use is console. Right? So if we go over here to Fabio and we hit F5, right, now we can see all of the different routes, right? And HT Africa is one of them. And if we change this here then to to-dos, right, we will get a blank JSON because our MongoDB is blank, right? And because this is an API that I've developed, I'm going to go ahead to Insomnia. And I'm just going to run this. And it's blank. Okay, yeah, I have nothing on it. So let's do let's create a task for us to do today. No, hello, HashiTalks. Rob, what do you have to do today, man, that you can't forget?
Okay, well, firstly, can we boost the text if possible a little bit, just so I can read that?
Try it.
Yeah, there we go. What do I have today? So today I am emceeing HashiTalks Africa. This is my second year in a row, so let's make something out of that, I guess.
Right. So hello, HashiTalks again. Yeah, and like and subscribe to Rob on Twitch. Do you have YouTube, Rob? And YouTube?
Yeah, well, yeah, I'm a big YouTuber, big YouTuber. I'm more active on YouTube than Twitch these days.
DevOps
man, Rob, look me up.
DevOps Rob. Actually, that's great. Okay, so now we added a couple of things, right? So now we can see here all of our APIs. And let's go ahead and update that. So let me just change this. And it's like and subscribe to DevOps Rob. Cool. Right. And now we can just come over here and check it again. Right. Cool. There we go. So it is working. And all of the complexity, again, if we think about, setting up a new CI/CD pipeline and getting there, all of the complexity of doing all of this has been done for me. And from a developer experience, all I needed to do was develop my application. One last thing before I go off, and one of the many reasons why I love Nomad, right? We currently have one instance running. So let's say, my to-do app is a big hit, and we need to scale this out. So one of the things that I can do, there are, of course, auto-scaling mechanisms that I can use, but if I need to do it manually, like right now, I can go ahead and do that, right? And off it goes. So from one instance, I now said that I want 15. And if I go back to my services here, I can actually see all of the 15 instances get deployed. right? And they are slowly getting
healthy.
Healthy. Thank you. Now, it won't make that much of a difference for us. And I closed my Fabio. I can open it again, no problem. Yank, we'll just come here. Right. Do right. It won't make that much difference for us for this use case, but if you think about scaling an application and the complexities of doing that manually, right, using the cloud operating model just facilitates that whole process. And now I do have another demo, which is this one, right, which I think showcases this more, which is a simple Nginx server, right, that is going off to Vault to generate my PKI certificate, right? And I can see here as I, pressing F5, we can see it's running different instances and it's doing that. And I think that's a little bit more visual of kind of that scaling feature that the integration between Nomad and Console provide. And the integration with Vault, as Rob was saying, it's a standard library to do things. So if we take a look, okay, what do we need from there? What does that look like? If I just come over to Nginx, Rob, is the size okay?
Yes, perfect. Perfect.
Mm-hmm. Right. The complexity of going to Vault to generate a short-lived 30 minutes PKI certificate for this instance of Nginx is this 3 lines of code. And
very
that's
simple templating as well.
Yeah. And I think that is the beauty of kind of the COM, right, of using all of these things together. Now, that's it from a visible showcase perspective. I do want to leave everyone here with just some kind of things that I've noticed, right? Process matters. And what I mean by that is what you do is less important than how you do it. It's like, you use GitHub and I use GitLab or Jenkins or whatever. It doesn't matter. Like what you are actually doing. Or instead of Nomad, it's Kubernetes, and instead of this is that. And how you do it and kind of automating and abstracting away that complexity is the important bit. Right? As we saw today, and I think the beauty of the whole event is this collaboration, right? And we talked about that. Right? And my son is here collaborating with me and wants to be part of the HashiTalks. That having kind of a place where it's like, you can go ahead and get this and use it from there, or let's improve on it and send in that pull request. It is important, and it is a constant gradual improvement. You do a little bit by a little bit, abstract a little bit of complexity away every single time, and we keep improving. And again, as we were talking about beforehand, self-service. So don't open a ticket. The more that you can have abstract away complexity so people can do it themselves, the better, right? As we saw in Victory's session today, right? Facilitating that onboarding experience as well on Anita, and like making sure that people will become part of the community in the least difficult way is key, right? Giving them the power to do things self-service is important, and dynamic. Use Vault, use dynamic secrets engine to facilitate that. So if you don't need to give a secret out to someone, like a database password that is long-lived or very powerful, a root user, you don't need to. And if it's just like, okay, this secret is only valid for this Terraform run. It's 5 minutes, it's an hour, it's a month, and changing that is easy, and that for sure will make a difference. Yeah, so thank you for bearing with me throughout the session. I hope it was useful, and I hope you like the session. I will, as soon as I log back onto YouTube, I will share out these repositories. But it is quite simple. I am going to destroy all of this, but it is Guy Barrows, or Guy Barrows, as Right. And the one that we saw, it is the Terraform Showcase, and the AWS is my platform itself, right? And if you want the Nomad jobs, it's just called Nomad Jobs. Documentation isn't my forte, and of course, PRs are for sure welcome. Yeah, and thank you.
Thank you so much, Guy. And you know what? You showed that you're a true developer when you say that documentation is not your forte. That's the that's the real mark. That's the authenticity right there.
It's like an improvement point. It's like, I know I should do it eventually.
Brilliant. Well, thank you once again for joining us. Thank you for an amazing showcase. If you want to read more about the cloud operating model, we'll do our best to share some links in the chat. Guy's going to hang out in the chat as well. So definitely, if you have any questions for Guy, then reach out to him. He's super approachable, super awesome, as you've seen. Yeah, thank you so much, Guy.
Thank you, everyone, and enjoy the rest of the event.
Brilliant. Right, so we are getting towards the end. We have reached the time where we have our final speaker for the day. And this one's another interesting one. It's Terraform based again. We are going to be looking at continuously deploying Terraform code with GitLab CI. A lot of people are using different CI/CD tools, especially when it comes to Terraform. But one of the things that I've noticed that people don't speak about a lot is GitLab, which has a huge community behind it. So really thrilled to hear this talk. So I have the pleasure of introducing to you Ido, who's going to give us this talk. So I'm going to hand it over to you now.
Hello, Rob. Can you hear me clearly?
I can indeed, yes.
All right, awesome. Welcome everyone to this talk. Basically, this talk will be focusing on discussing Terraform in collaboration with GitLab. Technically, from the beginning of the event, we've had a lot of people talk about Terraform. We've already talked about the well-architected framework. I was listening for the talk from Femi to talk about introduction to Terraform and GCP. I listened to Obina's talk. I listened to all the talks, and seems we all acquainted ourselves for people starting out with Terraform. We've all acquainted ourselves with what Terraform is, why we need Terraform, what benefit it comes with, and things like that. So in this talk, basically, I'll just be talking about some level of complexity that come with Terraform and how we can use a CI/CD pipeline, for instance, in this case, GitLab, to actually automate the deployment of our infrastructure and the deployment of our resources. Okay, so let's jump right in. Before I start, I will try to just do a quick introduction of myself. My name is Idowu. I am an SRE. I'm an SRE at West Wing. I have a certification for Terraform Associate, and I'm also part of the current AWS community builders for containers. Yeah, so just to do like a reintroduction to Terraform, I would just be talking about some key concepts that I will be demonstrating in a later slide. So first, from the official documentation, Terraform is an open source infrastructure as code software tool that provides consistent CLI workflow to manage hundreds of cloud services. So basically, what this translates to is that you can use Terraform to achieve the application lifecycle that you have for your normal day-to-day applications. You can use that you can use Terraform to achieve that for infrastructures where you do code reviews, you do pairing, and you do things like that. Yeah, so one of the concepts I'll be talking about is Terraform modules. Basically, you can look at this as a container that contains several resources, right? In which using them makes you view your infrastructure as in terms of architecture rather than individual objects. So instead of viewing your S3 bucket as a an individual resource, it could be part of an architecture that all provides not just the S3 bucket, but provides your ACLs and things like that. So you view that as an architecture instead of interacting with the individual what will I call it now? Individual resources, Terraform resources or cloud provider resources. Now, I'll also be talking about the Terraform workspace. Basically, the Terraform workspace is a concept in Terraform that allows you to manage several environments of your infrastructure without having to duplicate code or without having to make any changes to the configuration. So basically, you can deploy the same Terraform code base using Terraform workspace in, say, a development environment, staging environment, a production environment. And what this allows you to do is that with just few changes or no changes in some cases, you can have the same Terraform code base being deployed using Terraform workspace. Depending on the workspace you are in, you can use that to actually deploy in several environments. Right. So now let's move on to we'll look at the flow of how complex a Terraform code base can be. We'll look at how easy it is for your Terraform code base to grow as large as you can imagine. So we will look at a small size Terraform script, right? This is a small size Terraform script. You see that, say, this is fit for, say, someone is starting off with Terraform, starting off with a simple main.tf file, your output file and your variables file. Just 3 files, and you can actually deploy as much resource as you can. But as things begins to grow, as requirements begins to grow, as number of resources you're creating begins to grow, you transition to say a medium-sized Terraform code base where you start using things like modules. You start segregating modules into separate folders, and you still have your main.tf file. You still have your output file, your variables file to kind of manage, to kind of separate concerns and manage things differently. Now, this seems like a very good way, a very good thing to do to structure, like the folder structure, to structure your Terraform code base, right? But things could get more complex than this. So let's check a large size Terraform code base where you now begin to manage large infrastructures for several applications. For individual applications, you still have the modules, but now main.tf files and output files are actually in separate repository folders. Basically, this is kind of the folder structure we are at in our journey to Terraform at West Wing, because of the complexity of the applications to manage, and these applications have either specific or unique infrastructures that are not shared between several applications. All right, so let's talk about our deployments to GitLab a bit. Then we'll go to the demo. So first, our GitLab stage, our pipeline stages would be first. We have a Terraform format check, basically to check if our Terraform code base is in a standard style when it comes to formatting and things like that. Then the next stage, which is as like a part of the code quality checks, it would be to run a Terraform validate on our Terraform code base. Basically, what this will be doing is to actually validate the configuration we have written in our Terraform code base is actually a valid configuration. All right, and just after that, we'll then run the famous Terraform plan. Basically, it shows us the changes that is required based on the configuration we have, and it shows us what needs to be updated, what needs to be deleted, what needs to be created. And with that, we can make informed decisions on whether we should run Terraform apply, which is the next stage, or not. Talking about Terraform apply, basically Terraform apply is the last stage in our GitLab pipeline that would actually attempt to create or update this infrastructure. So we'll be looking at how this connects together, and how Terraform apply, which would be a manual step, will actually also trigger that. All right. Yeah. So this is just like a diagrammatic representation of what I just explained. So 4 stages. We have the format check, the Terraform validate, the Terraform plan. And what is unique about the Terraform plan stage is that we don't just run the plan. To make code review easier and seamless, I also added a bit of bash script in such a way that the Terraform changes would actually be printed as discussions on the merge request. That way, people, reviewers, don't need to visit every plan to see what changes. Just from the PR and the discussion on the PR, we can actually see what needs to change and then drop our comments just from there. All right. As we don't have much time, let's just quickly go into the demo, and then I would basically show everything we have. All right. I think my screen is big enough. If you can't see my screen, you can just drop a message in the chat. I can see the chat. All right. So basically, this is our Terraform code base. I would just be doing a quick walkthrough on what we have here and what this basically does. So first, I'll be going into our GitLab.ci pipeline. File. Basically, that's the file that triggers the pipeline. And what this does, what this contains, is just like first a reference to this references several CI files, basically based on the stages, and I'll be explaining that in a bit. And one very interesting thing we have here is this keyword, basically. And this is a GitLab specific keyword that allows us to run the same pipeline with just varying environment variables. So basically what we have here is we have 2 variables, workspace and app directory. The first one is stage, and the second one is, for the second variable, we have app1 and app2, which basically is exactly the same thing as the apps, the folder names we have here, which I'll be explaining in a bit. So what this does is, whatever job this is attached to, it runs the job for every permutation of this variables and other variables attached to it. So basically what we have here is we have a job that runs with the value of workspace and app directory as stage app1. We have another job that runs with the value of workspace as stage, but now the value of app directory as app2. Basically, that's the permutation that has been done. And this also would run for production, and the value for app directory will be app1, and we will see how we add this to every one of them. So let's just do a quick run through of all these stages, and then see how we connect to this global pipeline permutation. So first, we'll go to the format, and basically what this does is to do a format check in a recursive way. So independent of the number of folders or how nested these folders are, for every Terraform file, we can actually check if it obeys standard styling, and then fill the pipeline if it doesn't. So that's what this does. And basically, the use for the bash script here is just that whenever we're running a new pipeline, discussions on that pipeline created automatically from this script, it is basically cleaned up. That's what this bash script is here for. Basically, we'll be having, I'll be sharing this repo, so you can just have a second look at this bash script. Then Terraform validation, basically at this validate stage basically does for every workspace and for every directory. What it does is to run the Terraform validate, and like I explained earlier, this just check if our configuration is valid. And you can also see that we are referencing the parallel configuration or the parallel metrics that we have configured here. That this is just a reference to that. And it's the same as copying all this and then pasting it here, basically. So it's the same thing. So, but this helps us to reference it from every file and just have one place where we manage that. So this runs Terraform validate upon every merge request to check if the changes we are making are actually valid. And then we have the Terraform plan. This is huge, so I will just do a quick run through. Basically, what we're doing here is to install the necessary dependencies and also run a Terraform init. This just helps us. Helps us to show Terraform report on GitLab. I'll be showing that later. This long command. And basically, one of the important step, which is to select the right workspace. I'll run a Terraform init in that workspace, then run a plan based on that workspace, basically. And then basically this section is where we try to print out these Terraform changes into as discussions on the merge request. Basically, because of this flag that we have here, the detailed exit code flag, Terraform plan exits with some specific exit codes. And for 0, it means that no changes are found. For 1, it means there's an error. For 2, if the status code, the exit code for the Terraform plan command is 2, it means the changes were found. And basically, we want to be able to print in a tightly formatted way. We want to be able to print those changes to as discussions on the merge request. And we have a Terraform show here in the pipeline just to show you what we have, and we're converting it to a report, which we have as an alias here. And then we have an artifact. Now, this artifact section, basically what it does is to generate an artifact from the Terraform plan, so that when we end up running an apply, we are not running an apply against the script. We are running an apply against the file, the plan we have generated. So that way we try to have constant configuration, and we are not caught caught unaware if changes are made on the fly or in whatever way. Well, for our Terraform apply, we're actually using the plan that has been generated previously, not just running plan against the Terraform code base. Yeah. And for the Terraform apply, first you will notice at this point that it's a manual step because you don't want to make changes and automatically have a Terraform apply, right? So it's a manual step. Someone has to actually go there to trigger that step to make it work. And like the Terraform apply, we have to select the right workspace, run a Terraform init inside this workspace, and then a Terraform apply on the file that was generated in the previous step. All right, that's everything about the stages we have for our GitLab. I will just run through what we have for what we are trying to deploy. So first, in application 1, you see that it's a little bit complex. Basically what we're deploying is a simple S3 bucket. But in this case, I'm trying to show how modules can be referenced, how environment variables can be passed. How Terraform variables can be passed and things like that. So basically, you would see that we are just referencing the S3 module, which is available in the modules folder S3. And basically what we have here is the bucket itself, ACL, and also public access restrictions, basically. And you have the variables file, you have an output, which will be the bucket name. And in our main.tf, like I showed you earlier, we are just referencing this module, passing in the required variables, that's the bucket name and the tag. And we are also using a remote backend. Basically, I've configured this initially. The remote backend here is an S3 bucket also on AWS and a DynamoDB table, basically. So app1 deploys S3 and app2 deploys DynamoDB. And if you check, and then just a simple DynamoDB, this references the resource itself. So if you check our Terraform pipeline, you would see that for app 1, we are deploying for both stage and production. However, for app 2, we are only deploying for stage. So we would also see that in action. And just for reference purposes, you would see that In our values file, in our TF-bus file, we have the tags, and this is slightly different for production. Environment here is stage, and environment here for production. For production is the environment here is production. So I'm making a slight change here and then creating a pull request. I'll be creating a pull request, and then we can see all this in action, basically. So basically the change I'll be making is to the bucket name. Of course, we want to make it unique. So I will just add a unique string, yes, and then I'll be committing this. Just a random commit message. And then I'll push this to the development repo. I think I have a PR open already, so the pipeline should kick off. Okay, I have a PR open already. So basically, the new changes I just made, you would see that it's the pipeline will kick off in a minute. So I'm just opening the pipeline tab here, and I will refresh this. Okay, you will see that a new pipeline should be created now. This is the first step, which is the Terraform links stage. Basically, what this checks is the format of this checks the format, the styling, and the of our Terraform script. If it's formatted properly, you can see that this stage is successful, and this only runs on pull request. And the next stage, and you can see the parallel metrics here in action. You can see that for production app 1, you would see that we have Terraform validate, production, and app 1 here, and the pipeline is in running state. You will also see for stage app 1, the pipeline is in a running state also. And you would see for the last one, you will see that you see stage app 2 in a running state. And just to bring it back here, this is just basically based on the configuration we have set here. If I decide to add app 2 here, you would also see that we would have production app 2. But let me remove this and then if I refresh this, if I give this just a nice refresh, you would see that the validate stage is totally running, and we can go through each one of them and see what we have. So this at the top, you would actually see what we are running for. The stage is production. The folder or the application name is app 1. So, and for Terraform validate also for the stage, you will see the same thing. So it means every job name is unique based on the permutation we are working with. So and for the last one, then we have our plan stage. You will see that the plan also you will see that the plan is running. So the plan was also successful for each one of them. Now, the reason for the bogus batch script section was that instead of going through all these jobs, because these jobs could be as much as say 10 applications, it means you would have 10 times 2. If you have 2 stages, 2 workspaces, that's 20 pipelines. Instead of going through all these to check which one has changes, which one does not have, we on the pull request itself, you would see discussions on the pull request itself based on the job name. Terraform plan for the stage environment for application, the second application, you will see we are doing a create of what resource. You see all the changes here, and just with a quick scroll down, you would see every single one of them, and you don't have to go through 20 jobs, for instance, right? And this actually brings ease to the whole pipeline flow. Now, to actually see this work, because it's awesome enough that we can see all this, we can automate our pipeline, but to actually see this work is we have to run Terraform apply at some point. And if you check the apply step, you will see that it will only run for the main branch. It means we have to merge this pull request. So let's assume I've reviewed, 5 people have approved and things like that. I click on the nice button merge, and you will see that a new pipeline is triggered for the main branch. And the first thing it does is to run another plan, because that's one of the most important things when it comes to Terraform. You have to be sure what you are about to do is what you intend to do. So we'll run another plan for this, for all the jobs, for all the stages and applications and things like that. So once we run a plan, then our stage or our job for apply would be ready. So while this is running, I could just do a quick login to my AWS account to show you what we'll intend to see. Okay, so just refresh this. Okay, so this, of course, this were S3 buckets from the demo I did before the talk. But yeah, we'll be seeing a new one. I think the unique we added Quachi to this, so we'll be seeing the change. Just to also explain, the local application variable is coming from the locals.tf, which in this case is app1, and we have Terraform Workspace. Basically, when you're using the Terraform Workspace concept, the Terraform.workspace variables are available to you, which you can use to actually differentiate between environments. So in this case, I'm using it to differentiate between stage and production. So it means that for every S3 bucket created with just this, I can create the same with the same Terraform script or the same Terraform configuration. I will be able to create separate buckets for staging and production. So just a quick check on our pipeline. So I can close this since we're done with that. Yeah, just a quick check on our pipeline. We would see that our plan is done. Everything is green. Looks like today is a good day. And what I can do is I can just view this pipeline individually and then say, okay, first for app 1, or let's go with app 1 for staging, just to be on the safe side. I trigger the pipeline manually, and I can give this a quick refresh to see changes. And also, because I'm using S3 as my backend, and these backends are independent on each other, I can actually trigger all the pipelines at the same time. And none of them is blocking each other, because not only am I using S3 as my backend, I'm also ensuring that there's locking, Terraform state locking enabled in such a way that I'm using DynamoDB in such a way that these pipelines, these Terraform states cannot be edited or read from by 2 different processes. However, all these have different states. So I can actually run them simultaneously, and they should run independent of each other. So we can see here that the stage app 1 is actually done, and we can see the bucket, the nice looking bucket name here, which is app 1 stage quality. And if I give this a quick refresh, that should open. Yeah, so we can see this here. So if I just limit the view to this, yeah. So we can see our Terraform for production, and our bucket for production and our bucket for stage. And if I open this, you see it's just the normal S3 bucket that we are all used to, and everything looks nice and good. And then for app 2, I'm just giving this a quick refresh to see the latest status. Okay, there's an error for app 2. Okay, the table with this resource already exists, which is awesome. So I think I didn't clear up the other one. Now, this will also help us to see a quick change table. Okay, awesome. The table name already exists, so I'm going to be changing the table name, push one more time, and then see what we have. So for app 2, just doing a quick change, I'm also adding, let me add the same unique variable to create another one. And while we are here, while we are creating a new change, I would just make a quick change to what the application one that was successfully deployed, and then I'll come here and then add just make a quick change to the tag, and we'll see what that translates to. So a quick push, and then merge request, quick merge request out, and then yeah, just to make things faster. And the same flow happens from end to end. The Terraform format happens, the Terraform validate happens, the Terraform plan happens, and then I can merge, and we'll see that happen. So I can just click on this, just so but we'll still be able to see when the plan is running. We'll still be able to see the discussions here and then every other thing. While we're waiting for this, if you have any questions, you can actually drop questions in the YouTube chat, and I would actually see it because I have my eyes on the chat. All right. Okay, we have the validate is done and our plan is running. So remember, we made a simple change to the staging environment or the staging TLVARs for our application one. And for application two, what we did was to make a quick change to the DynamoDB name because our one already exists. And just giving this a quick refresh again. Trying to see what's happening. Okay. Okay. So I have a question which says, what do I think is the biggest difficulty when integrating Terraform with GitLab? For me personally, I have not experienced any level of difficulty when it comes to GitLab. Right. So I think the only difficulty I would say is that probably it's in the roadmap for the future, but I personally think that there should be an easier way to interact with there should be an easier way to interact with GitLab APIs. To interact with GitLab APIs. So for instance, I'm trying to post a message as a discussion on this particular MR. Provided I'm using GitLab, I'm within the GitLab environment, there should be easier ways to interact with or easier interfaces to interact with the GitLab API in such a way that with a simple GitLab CI keyword, I should be able to summarize all this into probably 2 lines. Yeah, I think that was the only difficulty, coming up with a perfect bash script that works for this use case. Okay, so we can see that our pipeline is done. Just to, yeah, the pipeline is met already, but we could also still see what we have to see basically. So what I'm showing is for app 2, you see stage app 2, we have the new DynamoDB table that will be created. However, for app 1, we'll see that we made a simple change, which is to change the tags, and you can actually see the changes that will be made and to what resource. So like that's one of the beautiful thing about this, like printing out these changes to the discussion. So I don't have to go through series of jobs to actually see it. I can see it on the pipeline, and if there is something that would cause a downtime or something, I can leave a comment for the person that created the pull request. All right, so doing a quick apply now, doing a quick apply now, we just need app 2. We just need to apply app 2, and I can just click on app 2 stage and then click apply, and we'll see this create a DynamoDB table based on the resource we just configured. Yeah, so in summary, we can actually see that it is possible to actually integrate it is possible to actually integrate your CI workflow. In this case, we are using GitLab for this purpose, but it's easy. We can easily integrate your CI workflow to your Terraform code base in such a way that it is a full-blown application lifecycle. So from code reviews to approvals to every single thing, in such a way that even someone joining your project for the first time doesn't need to know okay, how do I do Terraform apply, or do I have to wait for person A to finish apply before I run my own apply? So this way the pipeline handles everything that involves infrastructure changes and things like that. We see that our DynamoDB has been created successfully. So if I refresh this, you would see that we have a nice looking DynamoDB table, and it's in an active state. So that's basically everything I wanted to talk about today. Yeah, like I was saying earlier, GitLab CI makes things easy. So even your most complex Terraform code base, you can actually use GitLab CI to easily deploy your applications, your infrastructure to AWS. Yeah, thank you very much, everyone, for coming for this talk. I hope you guys have a nice day. Bye.
Thank you so much for that talk there. It was really interesting to see how there's different ways of deploying your Terraform code and how you can use things like GitLab CI to do this. I learned quite a bit from that myself personally. So we have now reached the end of this fabulous day, this fantastic event. One of the things I've really loved about today is the real togetherness, the real collaboration. I love the fact that the speakers that we've had today are hanging out in the chat, and they're collaborating with other speakers. They're commentating on each other's talks, and it's been really fantastic to see. So I just want to thank each and every one of you who's taken the time out to give us a talk. I also would like to thank everyone who has joined us throughout the day on the live stream, no matter where you are in the world. It's been like heartwarming just to see so many people from different countries just come together for us to learn from one another. So thank you so much. Quick plug, we have HashiConf EU coming up. I believe it's June the 20th to the 22nd. So we'll drop links in the chat if you're interested in registering and attending that. That will be both in person in Amsterdam, and we'll also have some portion of it virtual as well. But other than that, it's been another fantastic HashiTalks Africa, my favorite one of them all, biased obviously. So thank you so much, and I am really looking forward to seeing you next year for that. We have so many other events as well, so if you check out our events page, you'll be able to see what we have in store for the rest of the calendar year. But until then, take care of yourselves.